Once in a million, I find familiar places. They set off memories, memories of beautiful faces. Even if the sky is falling down, don't forget those memories. Caught in the moment, emotions rising and falling. Over and over, memories forever binding. Even if the world is tumbling down, don't forget those memories. Even if the sky is falling down, oh no, please don't forget those memories. Those memories. Those memories. Even if the world is tumbling down, don't forget those memories. Even if the sky is falling down, don't forget those memories. And even if the sky is falling down, oh no, please don't forget those memories.
Hello? Howdy. Yay, my audio seems to be working. That's good. I'm never quite sure until it happens. What, shall I reorganize things a bit so you can see shit? That's better. I know how to do this. Right. Anyway, I'm going to actually. Nope, not properties. I want filters. Filters. Let's turn the audio of this down a little bit. Maybe, yeah, maybe that. I think that's probably better. Because I noticed when I rewatched the VOD from yesterday, there's certain bits you struggled to hear me talk. Yeah, we'll see how this goes. If you're struggling to hear anything, do tell me. Anyway, should we start with Nvidia? Let's watch what Nvidia unveiled. Apparently this was, what time was this? This was 17 hours ago. Right. Well, Nvidia. Let's see what Nvidia unveiled. English. You speak.
Ready, go!
Once upon a time, it was all fun and games. Nvidia started off by making chips for video game machines. Graphics became serious business when people started using Nvidia for blockbuster movies, medical imaging devices, and the world's most powerful supercomputers. And then one day, researchers discovered that our technology was perfect for AI.
Wait. Are we just going to dive straight in by announcing, it's not really an announcement, but proclaiming that we no longer care about gamers because data center makes up more than half of our revenue now, so fuck you. Is that what we're doing? Because that seems what we're doing. That sounds like what she's saying.
Today, Nvidia is the engine of AI. Engineering the most advanced chips and systems, and the software that makes them sing. So robots can lend us a hand. Cars can drive themselves. And even the Earth can have a digital twin. We live to tackle the world's biggest challenges.
In fact.
And don't worry. We still love our fun and games.
It's a Jensen me.
Welcome to Computex. Our close partnership with the innovators in Taiwan is foundational to our work. We have a lot to cover today across the breadth of our company: gaming, robotics, data center, and of course, AI. Let's start there. AI is transforming large markets, and every day we work closely with our partners to help bring new AIs to life. We collaborate on the systems, the physical and software infrastructure, the AI frameworks and AI applications, a platform that is continuously growing. Data centers themselves are transforming into AI factories as companies manufacture intelligence to process every engagement, every product, every recommendation, to deliver great customer experiences. This transformation requires us to reimagine the data center at every level, from hardware to software, from chips to infrastructure to systems themselves. This data center transformation will drive massive business opportunities for our partners in Taiwan. Delivering AI factories for training and inference, combined with a continuously growing need for traditional high-performance computing, comprise a $150 billion market for our ecosystem partners. In addition, AI is enabling the new market of digital twins, where we can reproduce, virtually, the complex products the world wants to build and extend all the way to a digital twin of the world itself to study climate change. Digital twins opens up a new $150 billion market. A third workload is also emerging: cloud-based gaming. Streaming games from the cloud to all devices expands the data center market by another $100 billion. Combined, these workloads represent
wait, stop. Can we just
the data center
where's that phone?
market by another $100 billion.
Because I was thinking about this earlier today. Actually.
Combined, these workloads represent a $500 billion market opportunity
Where are you going too far?
that our partners can tap into by leveraging our open platform.
Anyway, cloud gaming. Well, I was thinking, I was playing the Switch earlier, and I was thinking, this is a mobile tablet device, essentially from 2014. That's when the Maxwell based ARM chip was produced, and first the Nvidia Tegra. That's when it was originally used in the Nvidia Shield. So in 2022, it's not that powerful a device. However, it's good enough. Get some okay. Get The Witcher 3. Get Doom and whatever. All these games running at pretty low resolution, but they are current last gen games running on what is now a decidedly mid-range tablet that costs £300. And it got me thinking. They showed a video there. They showed a phone of some description. I was just thinking, if you have a iPhone 13 or a Samsung Galaxy S, whatever number we're on, what you have in your hands is multiple times the performance of the Switch. You've got a pretty substantial gaming device right there. Not that you'd know it. Not that mobile gaming at all leverages that. There is no reason why, for example, if it weren't for Apple's own hubris, Apple TV could be a PS4 level console if they wanted. iPhone could be a, you could probably get some decent PS4, PS5 ports, iPhone and Samsung, and equivalent performance. If anyone really gave a shit. I think to an extent, cloud gaming is. Sorry, I just got distracted. I just got distracted by the captions asking, "Is anyone really gay?" What the fuck? Oh, Jesus Christ! In answer to your question, Google captions. Yes, anyone really is gay. What was I even saying? Completely lost my train of thought. Completely lost what I was saying. Anyway, yeah, you could. Oh, cloud gaming. It's an I don't like it. I don't like the idea of your games being on someone's servers. I'm not a fan of, Xbox Game Pass, whatever it's called, for that reason. I don't like Netflix for that reason. A number of times I've been watching something that has disappeared when I was partway through the series. That happens a lot. I hate that. I don't trust when it's running on someone else's PC. I don't trust that I won't lose that surface, won't lose access to that game, won't lose access to that hardware. But more than anything, as we're about to see later on with AMD and with the Steam Deck, integrated graphics are not actually terrible anymore, and at least next couple of generations going to be perfectly usable. So actually, the floor to decent gaming experience, hopefully, is about to lower some. So, and that's the reason you want cloud gaming, right? play games on your phone, to play games on your laptop. These are the examples they had. Where the
By a trillion open platform. Require us to community that our
wherever it was on this. But yeah, I mean, but if you can play games, modern games competently on your phone, if you play them competently on integrated graphics, then sure, you can get better by getting a more expensive or a console. But the floor of entry, the lower that is, the better. And with every graphics company, AMD, Nvidia, Intel, all having their own upscaling technology to mean that you don't have to run 1080p, get a decent. You can play it for 540p and upscale it, and it will look on a laptop, on a phone, tablet. I mean, we wouldn't see the difference. Obviously, blow it up to a big screen, and yeah, it will look shit. But anything.
partners
Anyway,
can
rant
tap
over.
into by leveraging our open platform. There are 4 key elements of this data center transformation that require us to reimagine these modern AI factories. First, we need 3 processors working in harmony to handle different aspects of these massive new workloads: CPUs, GPUs, and DPUs. CPUs manage the overall system, while GPUs are the workhorses that perform the computations, and DPUs handle network traffic securely and perform the in-network computing to optimize performance. Of course, as training scales up, faster interconnects are necessary to allow the compute to scale. These massive workloads consume exaflops of compute, so infrastructure that excels at energy efficiency ensures sustainability in AI factories. Nvidia GPUs are so efficient at compute that if all the world's current AI, HPC, and data analytics workloads were running on GPU servers, we estimate that we'd save over 12 trillion watt hours of electricity per year. That's
a
the
bit of
equivalent of taking 2 million cars off the road annually. Getting AI running in production requires both tools to manage development workflows and tools
Liquid,
to
how
run
you
the
doing?
models for inference. But it also requires tools to manage and deploy AI models among fleets of servers distributed across central and edge data centers. This requires robust software to run AI factory operations 24/7. Powering these modern AI factories requires end-to-end innovation at every level. These include Hopper GPUs, Grace CPUs, and the Bluefield DPUs as building blocks networked together by quantum and spectrum switches.
We're watching the
All of
Nvidia
these
keynote,
combine
the
to deliver
Computex
the
2022. This
infrastructure
was
of the data
uploaded
center of the future
17 hours ago.
that handles these massive workloads. Finally, getting all of this to run seamlessly
Also, he mentioned Hopper,
requires
which is the
NVIDIA
next
AI Enterprise
generation of
software, which delivers robust
architecture.
24/7 AI
One of the
deployment.
two.
At every scale, NVIDIA has worked on this entire canvas of innovation so that our partners can take advantage of our open platform to deliver state-of-the-art servers and
Mentioned
racks
CPUs.
for
You
the
didn't talk
modern
about
AI data
what
centers.
CPUs they're doing. I'm
Earlier
interested.
this year, NVIDIA announced the H100 GPU, the most advanced chip.
This is the Hopper. This is. This could be wrong, but I believe that Hopper is the data center architecture, and Ada or Lovelace, whichever they're going. But both is going to be the gaming one, but that could be wrong. That quite a bit of high bandwidth memory. Yeah, this is. The funny thing is, this wouldn't be that good at gaming. Very, very optimal. The 100 line used to be the very top end thing, but it's more. You get the 100 and the 102. 102 is sort of a more overall balance. This is really can't see the board at all. Yeah, actually. I mean that's a shit ton of power delivery right there. Yeah, this is gonna, the PDP of that thing would be probably quite a lot.
Chip ever built.
I haven't had a motherboard that didn't be over the board showing. I mean, if you look at the have a look. What have we got? RTX 3090 board. That's quite a lot of the board showing on that one, isn't it? That's an RTX 3090. That's substantially, I mean, smaller GPU compared to that. GDDR6X as opposed to HBM on the die. Still a lot of power delivery, but not quite as much. So yeah, that's the thing.
It's an order of magnitude leap in performance over A100. Built with a custom TSMC 4nm process, it features 6 groundbreaking inventions. A faster, more powerful tensor core, 6 times faster than its predecessor, Ampere. It's built to accelerate transformer networks, the most important deep learning model today.
Tensor cores, by the way, they basically 2x2 vector multiply. Matrix multipliers. Maybe just see a shitload of others, but even that one you could see a decent amount of. Yeah. That was So that was the board for a RTX 3090. If you took the cooler off, that would be the. There was quite a lot of the board showing compared to on this. What I was going to say is the tensor cores, as far as gaming goes, not that you'll be getting, but it's going to be similar architect, similar products that you will be gaming on, maybe. The tensor cores are what drives DLSS AI upscaling. So presumably if it's got 6 times the tensor performance, then that would imply less of a cost scaling, or maybe better upscaling. Maybe upscaling from 80p to 8K would be feasible. It'll definitely make those higher resolutions a lot more possible once you get the TVs that can handle it, because let's be honest, you actually can. If you want to spend far too much money, you can get a 120-inch massive TV. And if you only have to render, I mean, 1080p is a 16th of that, right? And you could interpolate the rest. And that's going to make that a lot more easy to drive without spending an arse ton of money on the sheer grunt to boost those. 8K TVs are so expensive at the moment, yes, but at some point they're going to become cheap enough that it's not outside the ordinary for people to buy them. And when that happens and you want to game on the things, you probably want to get a nice looking image. So I think even if it's not relevant now, the ability to produce an image that looks good on an 8K display will become relevant going forwards. And I'm not entirely sure that rendering an 8K image and gaming at that resolution is the way forward. I think the diminishing returns of doing that versus the cost of doing that are extreme, and they're not. Those costs aren't exactly going to go down unless you take shortcuts like DLSS. That's how tech works. Everything becomes affordable. Yeah. But there was all right. So we had the problem a few years ago. We had the problem where 4K monitors reached an affordability level well before the graphics cards needed to play nicely on them did, right? And that happened simultaneously with SLI dying out. So you couldn't even pair 2 graphics cards and do it that way. So if the displays have come down in price before the graphics technology to use them, then that's causing problems. And it did cause problems for people who got 4K monitors when you could get them for like £400 back in 2014, which is, not terrible. But you've only comfortably be able to use them with a single graphics card in 2020. So, yeah, I think even if 8K TVs are stupid now, I think looking for a next generation graphics card that can handle them is the right thing to do. Because by the time the CVs are affordable, you want to be able to use them.
The second generation multi-instance GPU.
Maybe it's late to the game. No, I just think that GPU technology needs to be looking more forward than it has done over the last few years. I bought a 4K TV last year. I mean, it depends, right? Because the 4K monitor above me, that was about 800. Actually, the 4K monitor in front of me was about £800. This 4K monitor next to me was £400. That was, and this is, when was 20? That's like 8 years ago, right? Remember 8 years of upgrades. And when I upgrade a monitor, I don't get rid of the old one. I just don't throw away tech. Maybe I should at some point, but I don't want to. So yeah, 4K is affordable. If you only want a 4K 60 hertz bog standard monitor, that is not expensive and hasn't been outlandish for a long time. You can go the other way. You can get 4K 144 hertz HDR OLEDs. You can do all of that, and that will make it expensive, but it's not the 4K itself that's the cause of the price. So I think we're going to get to a point relatively soon where, 4K back in 2013, 2013, you could get it, but it was limited to 30 hertz. It was not a great gaming experience, and they were like £2,000 for that. That's mine. Is the 4K OLED. Yeah, that's why it's expensive. It's the OLED part that makes it expensive. Has a nice image, but oof, yeah. OLEDs look gorgeous, especially now. They don't have. They seem to have fixed some of the issues that OLED used to have, like the screen burn-in and the image color shifts as you went from side to side. They are a lot better now than they were. Again, 2013. That's good. Technology improves as it goes on. But yeah, I think we're going to be in the point soon where you can get 8K for stupid money with shit specs apart from the number of pixels, like we did 4K in 2012, 2013, but it only took a year. It only took a year or so after that to get up to 60 hertz, which is fine. They're not cheap, but I think it's worth it. Depends on how much you have to spend. I think for my purposes, VA looks really nice. IPS looks really. I don't. But yeah, I quite like. Maybe my phone's OLED, and looking at the screen quality of that and watching films on that are surprisingly high quality. It's a lot better than It's all to do with the fact that it is. I love an 8K magnified. Notice much of my output isn't. But you wouldn't. It would have to be native content. The other thing is, my TV it's a 43-inch monitor. I use it as if it were. I sit on that sofa behind me, which is not that far away, and watch something that's 43-inch. I would struggle to see. Honestly, I'll struggle to see if that's 1080p. Actually, it's at that size and this distance. the 4K isn't strictly necessary. You get decent 1080p screens anymore. Don't make them. So I use my 60-inch TV as monitor. 60-inch, I might want to see a difference. I think if I went something stupid like 100-inch, 120-inch, I would definitely want an 8K display. And I'd want to game at 8K as well, because otherwise the pixels would be too big. Compare that with my monitor, which is 28-inch and is just over an arm's reach from me if I try to poke it. That's a SI unit of distance, obviously. That's 28-inch, and I would say that 5K or 6K would be the absolute limit of what I'll stop being able to see. I can see there's aliasing at 4K on it, but I have to look for it, and it doesn't bother me. Which is also nice. You actually get to turn off anti-aliasing and not care with 4K and above at this size, and it's a function of all three things: size, pixel density, and distance from the screen. The 60-inch is probably 2-3 arms reach. That's pretty close for 60-inch. I'm waving at my screen. I'm waving at my monitor trying to see how close it is. It's maybe 1.5 arms. 1080p on 4K. The really nice thing, the really nice thing about 4K, as a resolution, is 1080p is obviously a quarter of it. So there is a integer scaling between 1080p and 4K, which means all of the pixels on 4K can just double up, which means you get a crisp, not quite as good as native 1080p, but you get a crisp image of 1080p on that screen. If you were to look at 1080p on 1440p screen, for example, it would not be an integer scale. There would be a bit of a pixel left over, and it will be down to your monitor to handle the upscaling of that, and it would not do that well. So looking at 1080p on a 4040p, it would look fuzzy. It's the same reason why when everyone went to HD, went to 1080p and started watching DVD quality stuff, TV quality stuff, it looked fuzzy. People were like, I remember what this looking this awful. It's because liquid crystal displays do not handle sub-native resolution upscaling well, gracefully at all. Also, someone who watched crap on VHS, it's probably too. Yeah, it's also analog, which means that the pixels weren't well definition to begin with. But CRTs, brilliant. You could put any resolution to that, and it will display it as if it were native. They don't have a native resolution. They can just display anything. They're great. For that reason, they're great, and also a few other reasons. But 4K, 1080p is a native scaler, so if you watch Blu-ray on a 4K monitor, it will look great. The other nice thing about 4K is 720p is also an integer scale. Like 2160, instead of 4 times 1080p, is it 3 times, I think? Yeah, 720 to 2160. Yeah, so yeah, 720p is also a factor of 3840 by 2160. So that also looks crisper than, say, 720p content on a 1080p screen. So that's the other benefit of 4K. All of this lower resolution content also looks better. Not native, obviously, and it won't look like it's native 4K, but it will look better than it would on, a 1080p screen. Obviously, 1080p would not. It would look ideally about the same, but probably slightly better on the 1080p screen because it's not even an integer scale. It's just a scale, 1:1, which is the best scale of all. Anyway, I'm trying to get a VHS. Yeah, my dad's got one in the garage. Got some VHS I want to digitize too. but I kind of want to see what it looks like on a flat panel. I'm not expecting best. Right.
GPU partitions the GPU into smaller compute units that allow CSPs to divide each H100 into 7 separate instances. This greatly boosts the number of GPU clients available to data center users. Confidential computing allows customers to keep data secure while being processed, maintaining privacy and integrity from the
Have a
end-to-end
VHS
on
if you want
shared
it.
computing resources.
It's fine, thanks.
Our 4th generation
I
NVLink
have one. It's
allows
just
GPUs to
I know
communicate faster than
I
ever
know
before,
where one
at
is.
900 gigabytes a second bandwidth
Just
between
buried
server
under a
nodes,
amount of crap
and
at the moment.
scaling up to 256 GPUs to solve these massive workloads in AI factories of the future. The DPX instructions are dedicated cores that speed up recursive optimization problems like gene sequencing, protein folding, and route optimization up to 40 times faster.
Also have a Betamax.
For the larger scale
Nice.
AI factories that need to
I've
solve
never seen a
workloads like
Betamax in the
conversational
flesh.
AI agents and planet scale digital twins, NVLink now scales across servers. The new NVLink switches allow up to 256 GPUs or 32 HGX servers to communicate at NVLink speeds. This switch and interconnect network forms the NVLink switch system. NVLink switch system allows up to 20.5 terabytes of HBM3 memory
Oh, that's a
at an
lot.
incredible 768 terabytes a second of memory bandwidth.
That's a
This
lot.
delivers an exaflop of compute in a single pod. Truly, we have reimagined the data center. The performance boost over Ampere is incredible. Training the latest
Oh,
transformer
let's have a look at these graphs. From 5 days to 19 hours, 6 times faster training throughput. Machine learning training. Number of GPUs. I'm not reading that right. That's not 20,000. Right? These axes need better label.
models, the combined benefits of Hopper's raw horsepower, the new transformer engine with FP8 tensor core, NVLink with sharp in-network computing, and NVLink switch, as well as the latest Quantum 2 InfiniBand, results in a 9x speedup. Weeks turn into days. For inferencing, the benefit is even greater. H100's throughput is up.
Does Ampere do FP8? Because if it's only doing 20,000 GPU, I don't know what this actually means. I don't know if we're interpreting correctly. But what I will say is that if this going to do, I know Ampere can do 16-bit floating point. If Hopper only needs 8 bits of precision and Ampere can do that, that would constitute a lot of speed up, even without any other architectural improvement. Sure, there's
Up to 30 times higher over A100. It's the most significant leap we've ever delivered. Nvidia H100, the new engine of the world's AI infrastructure. Our Taiwan partners have helped accelerate the world's servers. Now, they're designing the world's next generation.
Yes, but the graph should also mean something.
With Nvidia accelerated computing. Let's take a closer look at the chips in our open platform that deliver this incredible acceleration. Here's Brian Kelleher to tell us more.
Thanks, Ian. NVIDIA has been built on a consistent flow of innovations and technology delivered through a new GPU architecture family every 2 years. NVIDIA focuses on inventions that solve new challenges and open new markets. Our work in accelerated computing, AI and machine learning, edge computing, and Omniverse are examples of how NVIDIA and our partners have created unserved new markets. We've established a reputation for unmatched roadmap execution, designing the world's most complex silicon with an expectation that the first silicon out of fab will go directly to production. That dependability helps align our company, and just as importantly, helps align our partners through trust in our roadmap. Our new data center roadmap includes 3 chips: CPU, GPU, and DPU. We'll extend our execution excellence and give each chip architecture a 2-year rhythm. 1 year will focus on x86 platforms, 1 year will focus on ARM platforms. Every year, you will see exciting new products from us. The Nvidia architecture and platforms will support x86 and ARM, whatever customers and markets prefer. 3 chips, yearly leaps, 1 architecture. Let's dive into the latest announcements and discuss the impacts to our partners' servers. Grace is our
This is the fun part. This is where I guess it does. Alder Lake, Intel's big little architecture. A lot of people are saying that it's because Intel is shit scared of AMD because of things like the 3990X, which is 64 core behemoth. The fact that AMD has got up to like 30% market share for the first time since like 2004, something like that. They're actually doing really well on Intel. 10th, 11th gen. Especially the 11th gen, it's floundering a bit. But honestly, I think Alder Lake, the move away from monolithic, homogeneous architectures is because of Nvidia. The reason Intel are producing a consumer graphics card this year is because of Nvidia. Here we have workloads that were traditionally CPU only, which Intel dominated. They practically destroyed AMD in the data center. It's taken this long, with successive generations of Ryzen, to build up AMD's presence as a professional CPU manufacturer. Like, okay, but AMD Radeon doesn't really exist in the professional setting anymore. CUDA, going back the last decades, destroyed that. And with AMD going all in on OpenCL is not really used by anything professional, unfortunately. I wish it were. I wish it were more widespread and more optimized generally, but it's not, which means that AMD graphics cards, especially now they've even lost Apple. That was another bad thing. AMD graphics card, if you use them for professional settings on Apple, where the only choice was Apple, only choice was AMD, yeah, that was saving them, for professional use for that end. But now AMD Radeon is basically just gaming GPUs, and they're good for that. Don't get me wrong, they are good for that, but it's the reason why AMD is the only company not to put some kind of machine learning capability on the graphics card. Intel and Nvidia are both doing that. And going back to my point about Intel, AMD, God, I'm saying the wrong company every fucking time. Nvidia. Yeah, they're still supporting x86. They've got to. If they want to maintain their presence in the data center, that's what's dug in. That's where all the history and the mind share and everything is. That's where people are right now. However, ARM, getting there in a big way. You can get some pretty nice 40, 60, 100 core, very low power ARM server CPUs. And Nvidia also don't have an x86 license. They cannot produce a competing chip with AMD or Intel. They would have to use AMD or an Intel CPU, and they don't have the best relationship with either of those, considering they are both their competitors. So they're pushing ARM, which is what you're seeing here. They are just like the Nintendo Switch. The Nintendo Switch is an Nvidia CPU, GPU that is ARM based on the CPU and uses a Maxwell GPU. Scale that up to the data center, and that's what they're pushing. And this is a future that there's this shit. Because not only does it not use Intel, doesn't even use x86. So at least when AMD comes and eats their lunch, they're still using Intel's architecture. They're still having the support of Intel stuff. And the software that runs on it will still use Intel. That's all. I mean, the two, Intel and AMD, are sort of Intel and, yeah, just bound together by decades of interlicensing with x86 and x86 64-bit extensions. Nvidia are not. Nvidia have no reason to put x86. If you want to know why Nvidia was trying to buy ARM, this is it. This could have been, as far as Nvidia is concerned, this could have been entirely theirs. They own the architecture, they own the CPU, they own the GPU. Everything about this could potentially have been a proprietary Nvidia unit. And I don't think Intel's monopoly was particularly good for anything. I don't think x86, even with AMD being as good as they are, I don't think x86 being the platform, the only platform, the only thing you have a choice to use, I don't think that's a good thing. Nvidia owning ARM, probably also not a good thing. Nvidia licensing ARM to really do some damage on Intel's monopoly, I can get behind that. But yeah, the more people using very fancy, very high-end, very high performance, very multi-core, very low power ARM CPUs in the data center, Intel clearly realized they've got to compete with AMD, and they've chosen an heterogeneous architecture to do that.
First data center CPU. Grace is built for AI workloads that have emerged only in the past few years. Grace is built to power AI factories, a new breed of data centers. Grace is on track to ship next year, and we have...
Oh, and on that subject, it's worth pointing out as well, I said AMD doesn't have any AI capabilities, machine learning capabilities on their graphics card. So, like, Nvidia has the tensor cores, which, you know, said earlier, they're 2x2 mate for machine learning. What AMD are doing is they're putting that on the CPUs. So the same 3D die stacking technology that went into the R7 5800X 3D to give it an obscene amount of cache, that technology is being used on their EPYC server processors in the future to, instead of add cache on the top of them, they're adding whatever their equivalent machine learning processing capability is. So that's going to be interesting to keep an eye on going forwards. Yeah, it's saying a lot. It's very telling that AMD have almost recognized that, well, trying to attack the data center from Radeon, not going to go so well. Trying to do it from Ryzen, they've already got a foothold there. That's probably the way to do it, and that's the way. Makes you wonder, though. Given what they tried with Smart Access Memory, which just turned out to be a branding for the sides will be AR, what if they had a DLSS equivalent for gaming that used the machine learning CPU? Means if you wanted AI upscaling on Radeon to have a Ryzen processor, I could see, it's gonna be shitty, because it would lock you into an ecosystem. It's no better than what Apple do. In fact, it's worse than what Apple do, because you can use an iPhone with some things are just better if you use them with a Mac, but there's not forcing you into individual devices. Whereas this would be bigger, but I could definitely see the technological pragmatism doing that.
Available in 2 form factors. Grace Hopper, shown on the left, is a single superchip module with a direct chip-to-chip connection between the Grace CPU and the Hopper GPU. The CPU and GPU communicate over NVLink C2C, a low-power, memory-coherent interconnect at 900 gigabytes per second. Grace will transfer data to Hopper 15 times faster than any other CPU can, and will increase the working data size of Hopper to up to 2 terabytes.
This is another thing you can't possibly get with x80. There is no way. If you go to Lenovo and you spend £40,000 on a data center server that's got either Intel or AMD and Nvidia, there is no way you're going to have a bus that good, that high bandwidth, that speed. This is definitely an attack on Intel. There is no doubt this is Nvidia are being incredibly aggressive. It said 900 gigabytes a second, right? Yeah. Interconnect at 900 gigabytes per second.
Grace will transfer data to Hopper 15 times faster than any other CPU can, and will increase the working data size of Hopper to up to 2 terabytes. Grace Hopper is built to accelerate the largest AI, HPC, cloud, and hyperscale workloads. We'll also offer Grace in a superchip made of 2 Grace CPU chips connected coherently over NVLink C2C. The Grace superchip has 144 CPU cores, an incredible 1 terabyte per second of memory bandwidth, and twice the
Remember I said about very high core count, little ARM CPU cores that are incredibly efficient, that just are going to wipe the floor with anything Intel has? Turns out my numbers were smaller than the actual reality here. 144 ARM cores. So very low power, very low performance individually. They are probably going to be in your phone the little cores that operate background tasks, but there's 144 of them, as opposed to, I think this is something like 4 and maybe 6 in total. Yeah. This is why Alder Lake uses Big Little. This is what Intel are seeing coming after their core business model going forward. This is why they can't just keep doing 24 core Xeons and calling it a day. This is why they can't just get multi-chip, multi-socket motherboards and operate NUMA between them and calling that a day. AMD have the right idea. AMD are apparently going for little cores later on, but even if they don't, their chiplet design, they can just whack as many. I mean, the 3990X has 8 Ryzen chips on it. It has effectively 8 3800Xs all sitting inside that socket together for a total of 64 big cores. There is no reason why they couldn't just keep piling more and more and more of them in there. As process technology gets smaller and those chiplets get tinier and tinier, there is no reason this model couldn't scale. If they made each chiplet 16 cores and then stuck 80 of them, that would be 128 CPU cores. Big CPU cores, not little. AMD have a very scalable model by design. They wanted to make one chip and be able to sell it in R3, R5, i7, R9, and Epic, and Threadripper, and cut all of their engineering costs down and just scale all of these up. And AMD have done that since Ryzen 1 in 2017 very effectively. And Nvidia's solution is to use ARM. So Intel has had to react fast, and Alder Lake is the solution. And the 12900K, yeah, it's a really good gaming CPU. Yeah, it's 8 big cores, 8 little cores, and yeah, if you game on the big cores and stream on the little cores, it's great. That's not why they're doing it. This is why they're doing that. This is the reason for Alder Lake. Intel are fucking terrified, and it's wonderful to see it.
4 CPU cores, an incredible 1 terabyte per second of memory bandwidth, and twice the energy efficiency of existing servers.
Which is the other benefit of ARM. There's a reason ARM exists in your phone, because there's a reason why a 6-core ARM chip will last me 2 days on battery. Scale that up to the data center and you want that level of energy efficiency.
Memory consumes only 500 watts. Grace is based on ARM, the world's most popular CPU architecture, and rapidly growing in hyperscale cloud and edge computing. Grace will be amazing at AI,
also
data
owned by
analytics,
Intel,
scientific computing, and hyperscale computing. And of course, the full suite of NVIDIA software platforms will run on Grace. The enabler for Grace Hopper and Grace Superchip is the ultra energy efficient, high-speed, memory-coherent NVLink chip-to-chip interconnect. Future NVIDIA chips, CPUs, GPUs, DPUs, NICs, and SoCs will integrate NVLink just like Grace.
Also, key thing to point out here, none of this actually affects gamers yet. However, you might remember SLI, Scalable Link Interface, the way of linking two graphics cards together, died as far as gaming went in 2016. I think Pascal was the last generation to support that. Turing did not, Ampere does not. Turing and Ampere do support NVIDIA Link, but only on the highest end chip. So you could, if you found a game that supported it, have two 3090s in SLI and run that one and only game using what is effectively SLI via the NVLink. However, what he's talking about is using that for two chips, presumably on the same board. They're going the AMD route and having multiple chiplets. Rather than what they do now, which is if they give TSMC a few million, possibly more dollars, they could effectively rent out an entire fab from TSMC and get them to make chips that are way bigger than they actually make, because they're not making them for anyone else. Now, if you have a limit on what they will sell to, Apple, AMD, now that Intel buying them for graphics cards. Whereas NVIDIA are like, no, if we pay you way more than what you're asking for anyone else, make this 700 mil squared monster. Which they did. That was it T100? No, that's a Terminator, isn't it? It's in the T100, something like that. It's one of those chips that was just massive. It was a behemoth. But there's no reason to keep doing that if you can just have multiple small graphics cards and just together. AMD are doing that. Nvidia have 5 patents to do that. AMD are already doing that with processors, so why not with graphics cards as well? Definitely the way forward.
And Hopper. Our SerDes technology
and they're going to use
NVIDIA
Link to do it.
Established over decades of designing high-speed memory interfaces, NVLinks, and networking switches. NVIDIA is making NVLink and our SerDes open to customers and partners who want to implement custom chips that connect to NVIDIA's platforms. In addition to NVLink C2C, NVIDIA will also support the developing UCIe standard announced earlier this year. With NVLink that scales from die to die, chip to chip, and system to system, we can configure Grace and Hopper to address a large diversity of workloads. We can create systems that range from Grace CPU only to accelerated with up to 8 Hopper GPUs. The composability of Grace and Hopper's NVLink gives us a vast number of ways to open new markets and address customers' diverse computing needs. Here's Yin to tell us more about these cutting-edge systems.
Thank you, Brian. Advanced technology needs world-class partners. Collaborating with the world's best system makers, we have created a broad array of data center solutions. Together, we offer hundreds of configurations of x86 and ARM systems to power the world's need for HPC and AI. And we are preparing new systems for Hopper and Bluefield. These systems are open for all partners to expand their markets by leveraging our ecosystem. Today, we're introducing Grace-based reference designs for the 5 massive new workloads of reimagined data centers. CGX for cloud gaming, OVX for digital twins and Omniverse, HGX for HPC and supercomputing, and last but not least, a new HGX architecture for AI. It features our most powerful AI training and inference platform using the Grace Hopper CPU GPU superchip module. All of these servers are optimized for NVIDIA accelerated computing software stacks and can be qualified as part of our NVIDIA certified system lineup. Let's take a closer look at 2 of the HGX systems. Today, we're announcing HGX Grace and HGX Grace Hopper systems. NVIDIA will provide the Grace Hopper and Grace CPU superchip modules, as well as their corresponding PCB reference designs. Both are specifically designed for OEM 2U high-density server chassis. Our partners can modify the reference design to quickly spin up the motherboard, leveraging their existing system architectures. Since OEMs already widely use the 2U high-density chassis, they can easily repurpose it to build Grace-based servers. We are pleased to announce these OEM hardware titans who will be part of the first wave of providers. The Grace systems will start shipping in the first half of 2023. Let's now talk about how we connect these servers to build racks and clusters with NVIDIA networking. Here's Michael Kagan to tell us more.
Thank you, Yang. The wave of AI sweeping the world is accelerating the demand for computing and creating new services that further demand even more data processing power. Data centers are becoming AI factories. This is the new unit of computing based on software-defined infrastructure delivering software-defined services. It is a single harmonic computing engine delivering millions of services to billions of users. NVIDIA networking solutions are based on 3 key components: Bluefield DPU, the data processing unit that connects compute nodes to the data center network, the InfiniBand quantum switch, and the Internet spectrum switch. The NVIDIA Bluefield DPU is the computing platform running the data center operating system. Bluefield offloads and accelerates networking and storage services, presenting virtual infrastructure at native bare metal performance. Bluefield is an essential part of cross-tenant performance and security isolation at the data center scale. Its operation is optimized automatically through built-in AI accelerators. Few months back, we introduced Bluefield 3, the 400 gigabit DPU. Bluefield 3 integrates high-performance compute cores, exposing fully programmable data path acceleration for network, security, and storage. Bluefield is a zero-trust infrastructure computing platform with hardware-based platform attestation and transparent, always-on data encryption. Docker is the infrastructure framework for cloud-native data center. It simplifies development of networking, storage, security, and infrastructure management services. Docker is designed to host certified third-party infrastructure services. The NVIDIA InfiniBand quantum network platform is designed for AI and HPC workloads. It is the foundation of cloud-native supercomputers that deliver bare metal performance with the convenience of cloud usage. The Nvidia Ethernet Spectrum networking platform is the fastest and most efficient Ethernet platform for the enterprise cloud data centers. Nvidia maintains a strict cadence, introducing a new generation networking platform every other year. This year, we introduced the 400 gigabit end-to-end networking platform, the fastest end-to-end network solution in the world. The Bluefield DPU, along with the Quantum and Spectrum networking switches, comprise the infrastructure platform for the AI factory of the future.
Thanks, Michael. Solving challenges with AI requires a full stack solution, and NVIDIA provides the software that brings these hardware innovations to life. NVIDIA AI Enterprise is a suite of software to power the end-to-end workflows of AI and data science. From data preparation and analytics with Rapids, to model training with TensorFlow, to real-time inferencing with Triton, you can think of this software as the operating system of AI. This software is fully supported by NVIDIA to run on leading enterprise platforms, from cloud to data center to edge, to help enterprises and organizations start AI projects and keep them on track. On top of this core software, NVIDIA has created frameworks to help solve specific challenges. For example, Riva is a framework for speech AI, Merlin for recommender systems, and Metropolis for vision AI. NVIDIA AI Enterprise is available through our partners around the world. When it comes to reimagining the data center, NVIDIA has the complete open platform of hardware and software to build the AI factories of the future. NVIDIA is Taiwan's partner to scale this technology portfolio into products to move from servers to racks to data centers that manufacture intelligence. We've talked about AI factories. Now let's talk about the next wave of AI, robotics. Here's Deepu Tala to tell you more.
Robots.
We are entering the age of robotics, autonomous machines that are keenly aware of their environment and that can make smart decisions about their actions. This drive towards automation makes robotics a major new application for AI. Across industries such as manufacturing, retail, agriculture, logistics and warehouses, delivery, and healthcare, we see a clear demand for automation. Robots of all forms and sizes, with wheels, with arms, with legs, with wings, on the ground, in the air,
They
underwater,
weren't wings, but
and
okay.
even robots that are stationary
Sweep
watching
that one
other
under the
things
rug.
that move and providing outside-in perception are increasingly being deployed. NVIDIA Isaac is a robotics platform. It has 4 pillars. The first pillar is about creating the AI, a very time-consuming and difficult process that we are making fast and easy. The second is simulating the operation of the robot in the virtual world before it is tried in the real world. It is far safer, cheaper, and faster for robots to be born in the virtual world before existing in the physical world. The third pillar is building the physical robots. We will show the tools that help bring real robots to market. Last, the fourth pillar is about managing the fleet of deployed robots over their lifetime.
As long as we're nice to the
Typically
machines,
many years,
it'll be
if not
fine.
more than a decade.
Every horror
Now
story
let's
that comes
double-click
from
into how we are
intelligent
simplifying the
robots
creation
comes
of
from
AI
people
for
mistreating
robotics.
them.
Training AI models requires data, lots of data. Capturing real-world data and human labeling is necessary, but not sufficient. With synthetic data generation, or SDG, corner cases can be added and model development bootstrapped. Image attributes such as lighting, textures, and colors
It
can
is
be
going to have
randomized
severe
to ensure
economic
diversity
impacts,
in the
though,
dataset.
when
And the SDG tool delivers the
Hardly
data
anyone
sets
can get a
with
job because they're all
perfectly
automated.
labeled data. Augmenting the real training data set with synthetic data is increasingly being used to improve accuracy and also reduce time to create or update an AI model. Using the Nvidia Omniverse platform, we have created Isaac Replicator for SDG in robotics applications. Starting with a good AI model dictates how fast the model can be adapted to a particular use case and target device. NVIDIA pre trained models vastly speed up the model creation time. Several of our customers have reported up to 10 times improvement. Imagine hiring an engineer for a critical job. You can hire a high school student and train them for a few years, starting from the basics, or you can select an experienced engineer and train them in a few weeks in the job's expertise. NVIDIA pre trained models.
Is this an analogy, or are you talking about literally doing that? Because if you're being literal and not using this as a metaphor, then how are you going to get experienced engineers if you don't?
In a few weeks in the job's expertise. NVIDIA pre trained models are essentially experienced
Okay,
engineers
it's a metaphor.
and are available on
Fair enough.
NGC for download. The NVIDIA TAO toolkit allows you to fill in the gaps. TAO stands for train, adapt, and optimize. You take a great engineer and then delta train them for your specific environment. You can take any model, whether it's an NVIDIA pre trained model or your own model, and use this toolkit to create AI models optimized for both accuracy and performance. Every month, we are seeing several thousands of downloads of our pre trained models and TAO toolkit. Synthetic data generation plus pre trained models and TAO greatly simplifies AI model creation. Make sure you try this out if you're building AI for robotics. Now, let's talk about the second pillar. Robotics is not easy, particularly building and testing a physical robot. Imagine you want to build a robot arm and it weighs 500 pounds
I could lift.
and it's made of solid metal,
I could lift.
capable of manipulation and gripping,
It could lift me.
and it needs to work with a human being in a manufacturing plant. I certainly do not want to be that human crash test dummy. Until it has been tested a million, billion times, I'm not going to be comfortable operating beside it. I don't mind being the human in the virtual world working with the robot in a simulation. We can simulate thousands of robots in parallel. Simulation makes it safe, cheap, and fast. NVIDIA Omniverse brings together high fidelity graphics and accurate physics to become a platform to simulate the real world, an environment for creating digital twins. Using NVIDIA Omniverse, we have built Isaac Sim for robotics. With Isaac Sim, various robot 3D models can be imported. All the robot sensors can also be imported. Isaac Sim can be interfaced with the ROS ecosystem. Several companies are using Isaac Sim for simulating both navigation and manipulation. Our focus on Isaac Sim is closing the sim to real gap, where the simulation closely matches what happens in the real world. Today, we are announcing Isaac Sim 2022.1 release, which introduces new features.
This guy's okay with it to the point where it's real. Got it. He said he didn't want to be the one to test it, which is fair enough, I think. I think if you are testing it for 1,000,000 hours in the digital environment before doing testing in the real environment, that's better than having it with no testing whatsoever and doing the 1,000,000 hours testing IRL with this thing next to you. I think someone has to test it though. Eventually they will. Eventually they will, but I think the idea is you'll see a lot of the bugs and bad behaviors in the simulated version before it got to the point where you are
Features that make
doing
it
it
the simulator for the age of AI robotics.
IRL.
Features include a new tool called Cortex, which makes it easy to program cobots, like the large robot arm I mentioned earlier. We also have added Isaac Gym, which allows reinforcement learning to be leveraged to train robot control policies in minutes as opposed to days. Along with SDG capabilities of Replicator mentioned earlier, these new tools bring the power of NVIDIA AI to robotics simulation. Now let's take a look at the demo of Isaac Sim in action.
Successful development, training, and testing of complex robots for real-world applications demand high-fidelity simulation and accurate physics. Built on Nvidia's Omniverse platform, Isaac Sim combines immersive, physically accurate, photorealistic environments with complex virtual robots. Let's look at 3 very different AI-based robots being developed by our partners using Isaac Sim. Fraunhofer IML, a technology leader in logistics, uses NVIDIA Isaac Sim for the virtual development of Obelix, a highly dynamic indoor-outdoor autonomous mobile robot, or
I'm not sure that's
AMR.
entirely how it works,
After importing
Liquid.
over 5,400 parts from CAD and rigging with Omniverse physics, the virtual robot moves just as deftly in simulation as it does in the real world. This not only accelerates virtual development, but also enables scaling to larger scenarios. Next, Festo, well known for industrial automation, uses Isaac Sim to develop intelligence skills for collaborative robots or cobots requiring acute awareness of their environment, human partners, and tasks. Festo uses Cortex, an Isaac Sim tool that dramatically simplifies programming cobot skills. For perception, AI models used in this task were trained using only synthetic data generated by Isaac Replicator. Finally, there's Animal, a robot dog developed by a leading robotics research group from ETH Zurich and Swiss Smile. Using end-to-end GPU-accelerated reinforcement learning, Animal, whose feet were replaced with wheels, learned to walk over urban terrain within minutes rather than weeks using NVIDIA's Isaac Gym training tool. The locomotion policy was verified in Isaac Sim and deployed on a real Animal. This is a compelling demonstration of simulator training for real-world deployment. From training perception and policies to hardware in-loop, Isaac Sim is the tool to build AI-based robots that are born in simulation to work and play in the real world.
So we talked about the first 2 pillars of NVIDIA robotics platform. Now let's switch gears and talk about building real-world physical robots and deploying them. NVIDIA Jetson has become the de facto AI platform for edge and robotics applications. Jetson has over 1 million developers, and over 6,000 companies are using Jetson for production.
Because the dog died.
With
Not if
over
the simulation does
150
its job.
partners ranging from system builders to application software companies, the breadth of edge AI and robotics products being deployed continues to grow. Sharing the same architecture as NVIDIA data center platforms allows us to run the latest and greatest AI cloud-native software on physical robots. We call this Jetpack SDK.
This is awesome. I feel like
DeepStream
NVIDIA's just
SDK
flexing. This is
being
definitely the
downloaded
direction
more than
engineering is
10,000
going in.
times every month and accelerates vision AI applications.
From the cloud
Viva,
processing
our
to the
conversational
AI to the
SDK is
simulation,
now
this is
available on Jetson.
definitely
We've
the
been working with Open Robotics
direction of
to
the industry.
accelerate ROS on GPUs. We call it Isaac ROS. In addition, we have several robotics algorithms available. We call them Isaac Gems. There has never been a better time to build robots with all of the NVIDIA Isaac software tools
Is
now
going to help
available.
disabled people. I think,
And we continue to
not
add and
directly, but I
improve
think the
software
technology will trickle down to
stack.
healthcare
NVIDIA
providers.
Orin has set a new bar
providers.
for edge AI as evidenced by the recent MLPerf competition. Up to
There's
5
an
times
awful
measured
lot of
performance over previous generation
bioengineer is not the
while
right words,
maintaining
but
100% software and form factor compatibility.
engineering in a
Powered by
biological
Ampere Tensor Core
context,
GPU and 12 ARM A78
aiding
CPUs,
with disability
it
and things like
delivers
that.
up to
That's definitely a massive area of
275
engineering.
operations per second. Basically,
And it's a
server
massively
in the
increasing area
palm
of
your
engineering
hand.
as well.
The Jetson AGX Orin developer kit is available now at distributors worldwide. Production modules starting at $399 will be available starting in July. The Orin NX module is just 70 by 45 millimeter size for the full computer. CPU,
I mean,
GPU,
yeah, but that's
networking,
kind of not
memory,
really
and
their
power
job.
management.
Their job is to create
Production
the
systems from
infrastructure that is
partners with
used
Jetson
rather than to
Orin
actually
are
use the
available
infrastructure.
now.
It's like
Many
it's like
partners
saying,
are announcing their products this week at Computex. More than 10 partners
um,
are in Taiwan.
road
These systems
maintainers
come in various form
who,
factors, tailored towards
fill
specific
potholes don't
industries
drive
and use
lorries.
cases.
Well, no, they don't.
Systems come as
Actually,
fanless or with a fan,
they maintain
varying
the road.
degrees
They
of
don't use the
I/O,
road. Well, they
ruggedized or commercial,
but
and other such
not for
parameters.
that purpose.
Autonomous mobile robots are one of the fastest growing segments of robotics due to the growth of e-commerce, supply chain challenges, and shortage of labor. In addition to warehouses, AMRs are being deployed in hospitals, retail stores, factories, campuses, and airports. The technology challenge is that AMRs operate in highly unstructured environments, even though they move slowly. To accelerate the development of AMRs, we created Nova Orin. Nova Orin is a reference design for state of the art compute and sensors for AMRs. It consists of two Jetson AGX Orin and supports multiple sensors such as two stereo cameras, four wide angle cameras, two 2D LiDARs, one 3D LiDAR, and up to 8 ultrasonic sensors. The reference architecture will be available later this year. The software stack on Nova Orin will consist of the navigation stack along with additional NVIDIA software application frameworks such as DeepMap, CoOpt, and Metropolis. DeepMap provides an accelerated framework for 3D map creation, deployment, and dynamic updates of the deployment space. CoOpt provides accurate dynamic route planning and scale out capabilities to hundreds, if not thousands, of AMRs in a single large warehouse or factory. Metropolis brings outside in perception and situational awareness, while the AMR itself can only do inside out perception. And finally, NVIDIA Fleet Command provides a secure fleet management capability. Today, we talked about the NVIDIA robotics platform, the four pillars: AI training, simulation, building physical robots, and deploying robots. This is possible because we leverage NVIDIA investments in AI,
At the moment, I'm more
high-performance
interested in
computing,
how
and graphics
these
from the
technologies
bottom
can
to top
be
of the stack, starting with hardware
implemented,
systems
what the
and system
various
software
uses,
to
and ultimately
AI
that
and
comes down to
Omniverse
the
platforms,
ingenuity of
and finally to
individual
domain-specific
engineers.
application frameworks. This is the industry's most comprehensive end-to-end robotics platform, and we continue to invest in it. Happy roboting. And one more thing, Drive Hyperion is the computing and sensing architecture of our self-driving car. It is central to our entire AV platform. It consists of sensors, networks, chauffeur AV computers, a concierge AI computer, a mission recorder, and safety and cybersecurity systems. Hyperion is designed for a full self-driving car with a 360-degree camera, radar, LiDAR, and ultrasonic sensor suite. Importantly, it is open for the entire industry, enabling them to build all types of vehicles. This is a key reason why Hyperion is being adopted all over the world. Hyperion version 8 will ship in all new Mercedes Benz vehicles starting in 2024, followed by Jaguar and Land Rover cars and SUVs in 2025. This platform evolves and has a great future roadmap. At our most recent
Did he just say I
GTC,
could have a
we announced
self-driving Land
Hyperion 9
Rover?
for car shipping starting in
Take take
2026.
me off road and not in the way Tesla do.
Hyperion 9 will have 14 cameras, 9 radars, 3 LiDARs, and 20 ultrasonic sensors. It will process twice the amount of sensor data compared to Hyperion 8, further enhancing safety and extending the operating domains of full self-driving. Today, we are excited to announce Foxconn, Quanta Computer, and Desai as our newest Drive Hyperion supplier partners to help OEMs scale this breakthrough technology into production. Now, let's talk about where it all began: NVIDIA gaming.
Wow, the
Here's
bit we're
Jeff
actually here for. We are 35 minutes in. I jest. This has actually been interesting so far. But let's be real, this is the bit we're here for. Hey, can this be available for Linux? Por favor? Particularly RTX voice. I really liked RTX voice when I was on Windows.
Hi everyone, this is our third virtual conference.
I remember him.
And like you, I am eager to get back in person to see all our great friends and partners. Taiwan is the birthplace of the PC ecosystem, and the spirit of Computex is to celebrate the incredible journey that built this $500 billion industry. Nvidia's journey started here as well, and together with our amazing partners, we are delighting and empowering hundreds of millions of gamers and creators. Over the past 20 years, we launched multiple generations of gaming GPU architectures, each pushing the industry forward. Our latest, Nvidia RTX, introduced real-time ray tracing and AI, once again reinventing graphics. We turned Max-Q into a game-changing approach to laptop system design. Beefy, transportable desktops have transformed into thin, portable powerhouses.
Not a fan of Max
And we
Q.
look beyond the PC into gaming monitors, showing...
What I don't like about Max Q is that it does it by massively downclocking the GPU. Which, okay, you can expect that because thin and light. However, what it means is that if you're comparing laptops and you're comparing a 3080 with a 3070, there are cases where the 3070 will be the better performer because it's not in a thin and light. So if you have a 3080 Max Q, it could be worse than a 3070 not Max Q. And it makes buying a laptop and knowing where they slot next to each other a lot more confusing. I don't begrudge the idea. I would argue instead that maybe we shouldn't be putting a 3080 in a thin and light in the first place. If you need to massively downclock it like that in order to cool the fucking thing. That would be where I would edge to. But yeah, I think buying laptops are already confused. Laptops, CPU naming, GPU performance, relatively, it's all a fucking mess. It's forever. I don't see that change. As long as you thing is, you buy an i7 for a desktop, you know what the general specs are going to be. You know what i7 means. I mean, granted, it's changed a bit because of Alder Lake, but generally, you know, okay, you're going to get. Previously, it used to be 4 cores with hyperthreading. Then it went up to 6 cores with hyperthreading. Then it went up to 8 cores without. Okay, maybe Intel's a bad example. They've been really fucking. You know, if you know AMD, you know what an R5 is? 6 cores with SMT. You know what an R7 is? 8 cores with SMT. You know what an R9 is? Either 12 or 16 cores with SMT. Like they're the defined boundaries. AMD are doing what Intel used to do. Makes sense. But for a laptop, you can get an i7 with like 4 cores. Is it an i7? How is it an i7? How is it better than i5 with 6 cores? Is comparable? You know? Who fucking knows? What is the logic? There is none. It's not relative. For a long time, you could get an Intel-based Mac that was an i7 with 2 cores. A dual-core i7. Like, yeah, it's marketing. It's the only reason Apple can say, oh, look, we put an i7 in this laptop. How good is that? But yeah, I hate how muddy the waters are, and this just makes it even muddier.
The world
Laptops.
buttery smooth gaming with Nvidia G-Sync and setting the standard for image quality. And let's consider the market we have built together. PC game hardware is projected to be a $67 billion market this year and to grow double digits over each of the next several years.
How?
100 million new PC gamers were added to our ranks.
Wait, how? How can we have this constant growth? Bear in mind, we're talking about a group of people who, a lot of people got into PC gaming and building a PC in the first place because they suddenly found themselves working from home, learning from home, for a year. They needed a PC to do their work, and they figured they may as well build a decent one they can game on as well, because why not? That's always been the allure of PC gaming. Like, do I get a laptop and a desktop, or a console and a laptop? When, yeah, a gaming PC is more expensive than either, but it's certainly not more expensive than both most of the time. So a lot of people doing that. That's why one of the causes of the massive massive demand jump during COVID, during lockdown, coupled with that, with the massive supply issues that are still ongoing. Sending anything by shipping right now is still a colossal undertaking. Even without shortages of like chips and resistors and capacitors and TVs and all that stuff, that the tail end of that is going to last on to the year. I don't see how the demand is going to keep exponentially growing. I don't think that's sustainable. I think it's madness to assume it's going to stay always going up. But then again, that's cap. Oh, unending growth. Is there such a thing as unending growth? No. Mention the bus because got my head in the sand. Rosie, I'm gonna stay Rosie forever.
In just the past 2 years, 80 million creators and broadcasters are fueling an economy of $100 billion. 920 million people will watch game live streaming this year, up 1.5 times in the last 3 years, and over 500 million people will watch esports. To our partners, thank you again for the commitment and passion to deliver amazing products that inspire gamers and creators year after year. Nvidia remains dedicated to building the ultimate platform for gamers and creators.
Great, bring RTX voice to Linux then.
GeForce RTX, powered by our Ampere architecture. With 28 billion transistors, 40 shader teraflops, 78 RT teraflops, and 320 tensor teraflops, it is the world's fastest GPU. Ampere features second-generation RT cores for real-time ray trace cinematic graphics, and third-generation tensor cores, which power NVIDIA DLSS, our groundbreaking
This is
AI
nice, but you're talking about
technology.
products that release in 2020.
For competitive gamers, we invented NVIDIA Reflex, providing the
going?
lowest latency and best responsiveness. For
So
game
third
live
generation
streamers,
RT, you're
the
actually
RTX platform
you're
includes
actually
NVIDIA's
acknowledging the
advanced
existence of
video
Volta.
encoder, engineered to deliver the highest
Interesting.
quality video stream alongside maximum game performance. RTX is also your AI-powered home studio. Our broadcast app leverages Ampere's dedicated
What it's worth, could you use DLSS? Given that was first generation tensor cores, I don't think you could. I don't think people who had the Titan V could use DLSS.
tensor cores
Don't
to turn any room into
Don't
a
know
live
anyone who had
streaming
that car.
station. For digital artists, we built NVIDIA Studio, an RTX-powered platform that includes dozens of SDKs and accelerates the top creative apps and tools, including NVIDIA Omniverse. Finally, the RTX platform is constantly optimized and improved with game-ready and studio drivers. Our customers depend on GeForce to just work across every system configuration and thousands of games and apps out of the box every time. Our drivers are an invisible force that makes our platform like none other. We are so proud of this effort, I invited Thiru to tell you more.
At Nvidia, we want gamers and creators to get the best gaming and app experience on day zero. We work closely with developers to ensure our drivers deliver the best possible performance and the reliability you count on.
To be fair, this is something
do
Nvidia
more
do really
and
well.
create faster.
For many years, we're working
On the subject, AMD just released a statement. Not, they just released an announcement where they told about a bunch of DirectX 11 games that have just got various performance boosts, and they went back a few years, and one of them was The Witcher 3, which is a game that was released in 2015. They are still releasing, they're still patching old games in their driver to get performance boosts, which on the one hand is good. Like, you have those cars, you're still getting improvements. On the other hand, what it belies the fact that AMD's day one support is not great. And Nvidia's game ready drivers that are released day one, that were produced way in advance of the game actually being released, are extremely good, to the point where it can take AMD's driver, I mean, I was going to say a year to catch up. This is seven. Nvidia's Windows drivers are very good. Actually, Nvidia's Linux driver, proprietary driver, problems you get from it aren't due to the driver itself. It's due to the fact that if you update your kernel and your driver is for an old version of your kernel, it can fuck things up. The AMD Linux driver works so much better because it's open source, because it's in the kernel already. It's when you update your kernel, you update it together as one object, so it doesn't fall apart. Whereas the Nvidia one, because you update the kernel, it's like you're wiping out the foundation of a building and whacking a new one in, expecting the building to stay stationary. That's the cause of the problems. Yeah, I'm hoping that because Nvidia are open sourcing the kernel modules, at the very least it will make upgrading your OS and upgrading your kernel in particular a lot smoother than it has been, and that will iron out a lot of the problems that, from a usability point of view, you have with the proprietary Nvidia driver on Linux. In terms of the ideological reasons, a lot of people don't like having a proprietary driver at all, and would rather use the source one. Fine, can do that if you want. To be honest, I would rather that. But from a pragmatism work, then be bogged down. I think when they have a working proprietary driver that handles kernel upgrades gracefully without requiring fixing, particularly if you're on a rolling release, I think then we can start to argue about whether it would be nice to have a better proprietary or open source driver. Yeah. And also, beggars can't be choosers. Have fun in the chip shortage picking one brand over another because you really want the ideological. No, you buy what is available. That's 2020, 21 gaming. You know, if you need something and something's available and it's not ridiculously overly expensive thing.
Work closely with the Nvidia team. It's like a safety net of constant cooperation on making sure that the drivers are supporting the latest updates in optimization on both ends, and that secures the gameplay experience for all the players. If you really want to see the game at its best, the way we actually imagined, the way we designed it, you need to get the game-ready drivers.
Our engine is so purpose-built and finely tuned to give you the best experience playing Doom Eternal.
Although, to be fair, what Cyberpunk needed wasn't game-ready drivers, it was a game-ready game. I think that would have been an improvement.
NVIDIA Studio drivers provide our artists, creators, and 3D developers the best performance and reliability. As I always say, it's very hard math to get these things to work, and the companies are working together to ensure that we're doing the math so our creators don't have to.
Our mission with drivers is to be invisible, so gamers can just play and creators can just create faster than ever.
RTX momentum continues to build. The cinematic look of ray tracing and performance-boosting AI are defining the next generation of content.
I still don't have a game that supports
now, there are
either
over
ray tracing
250
or
RTX games and
DLSS.
applications, doubling since last Computex.
And
GeForce gamers continue to upgrade, with over 30% now on RTX and logging over 1.5 billion hours of playtime with RTX on. Agent 47 returned to Hitman 3 in this dramatic conclusion of IO Interactive's Hitman trilogy, which has sold over 50 million copies. I'm happy to announce that today, the most successful game of the franchise is getting a big update with ray trace reflections, shadows, and Nvidia DLSS. Let's take a look at Hitman 3 with RTX on.
Of course, their compression is so bad that you can't actually tell what resolution it looks like. So yeah, the DLSS version is always going to look as good as native because
the popularity of Formula One racing continues to grow, as does Codemasters' F1 racing game.
I know DLSS is good.
That the next season,
like,
F1
there will be artifacts a bit, and their compression will not make any of them visible. And you're even better. You're seeing it twice compressed because I'm compressing it as well.
Ray tracing and the performance of DLSS. Hitman 3 and F1 22 add to the RTX momentum and join a number of new games that will be turning RTX on. Now let's talk about Nvidia Reflex. Immersive gameplay requires low latency. It connects your mind to the game. It's also critical for competitive gaming. It seems obvious that low system latency helps all gamers, not just the pros. But by how much? To measure this, we recently conducted the System Latency Challenge,
they've got that mouse
the
test,
largest
haven't
study
they?
of its type. Partnering with Kovacs, the popular aim trainer, we collected data from 20,000 gamers, measuring aim accuracy across a range of system latencies, from 25 milliseconds to 85 milliseconds.
Ooh.
What we found was interesting. High-skilled gamers, or the top 25%, hit 2 times the number of targets at low latency. And the least skilled gamers, or the bottom 25%, increased their shot accuracy by 2.5 times. Here's Tion to tell you more about
TLDR, even if you're shit, this benefits you.
Gaming performance isn't just about FPS. It also involves latency. We created Nvidia Reflex to reduce system latency. By integrating Reflex directly into games, we cut latency in half. Over 35 games
For my old
have adopted
TV,
Reflex, including 8 out of the top 10
think
shooters.
when I didn't
Now,
measure
over
this, I didn't
20
have the
million
means to do it,
gamers
but I
play with
think
Reflex on
when game
each
mode was off, I was getting about 100 milliseconds of latency.
Coordinate to dynamically reduce system latency. Gamers should definitely turn on Reflex. It's one of the first settings I turn on when I'm playing a game that supports it, and in Valorant we turn it on by default on hardware that supports it.
When you think about it, targeting 60 frames per second, every frame is only 16.6 milliseconds long. On PC, competitive players are trying to get higher and higher frame rates, 100 frames a second, 200 frames a second. When you get to those numbers, frames happen in just a handful of milliseconds. So being able to reduce system latency by 2 milliseconds, that's a really big impact for players. Nvidia Reflex was really easy for us to integrate into Fortnite. And in fact, we made it a plugin in Unreal Engine so that all Unreal Engine developers can easily enable it in their games as well.
The Reflex ecosystem continues to grow. In addition to games, it is featured in 22 monitors and 45 mice. This will soon include Icarus, a gritty PvE survival game where you explore a savage alien wilderness in the aftermath of terraforming gone wrong. Icarus, which already features DLSS, adds Reflex next month, so every gamer can better survive this hostile environment. Today, we are introducing the newest member of the Reflex family, the ASUS ROG Swift 500Hz gaming monitor. The lowest latency, highest refresh rate G-Sync esports display ever created. It has been designed from the ground up for competitive gaming, featuring a brand new ETN panel for maximum motion clarity. G-Sync.
Wow, so okay. Giving you a reason to want a 3080 with a 1080p display, 500 Hz. What CPU can even manage that? 5800 XCD struggles. It's not going to give you 500 FPS very often. Maybe in esports titles. Still. Also, another reason to keep TN alive, because over 2 milliseconds. I could have. You work something out and you 2 milliseconds. That's not long at all. Can they? I mean, I know TN is one of the fastest panel type. Can TN switch? There, it can take a 500 Hz signal. Can the liquid crystal actually change in 2 milliseconds?
Esports
I don't know.
With adjustable vibrance and, of course, the Nvidia Reflex Analyzer. Gamers, creators, and students have made GeForce high-performance laptops the fastest-growing
technology
PC
could
category.
do it. It would be TN.
Over 60 million people are gaming and creating on them. And this past year,
TN is advertised as 1 millisecond,
more
isn't
RTX
it?
laptops were sold, with 3x growth in studio laptops. Today, there are over 180 models for gamers and creators that feature our RTX 30 series GPUs and Max-Q technologies. Since we introduced Max-Q technologies at Computex 5 years ago, it has transformed GeForce laptops into thin and high-performance machines. This year, we announced 4th Gen Max-Q, bringing new innovations and even more power efficiency. CPU Optimizer allows the GPU to balance system performance and power. It utilizes a new low-level framework we developed with CPU vendors to improve power efficiency and boost frame rates. Rapid core scaling delivers more performance for creators on the go. The GPU can sense the real-time demands of the application and scale to the optimum number of cores for a performance boost of up to 3 times. Battery Boost 2.0 enables gamers to play for longer while unplugged by finding the optimal balance of GPU and CPU power usage, battery discharge, and image quality. And Advanced Optimus delivers the smooth, stutter-free gameplay of G-Sync while offering better performance, latency, and longer battery life. At Computex, we are showcasing new gaming laptops from MSI, ASUS, Gigabyte, and others. These gaming laptops feature cutting-edge designs and the incredible performance of RTX 3080 Ti and 3070 Ti. There are also exciting
Wait. I was just about to say I hate the way they say Ti, and then he said Ti.
RTX 3080 Ti and 3070 Ti.
Standards, what are they? Nvidia, you're just fucking trolling us at this point. Is it Ti or Ti?
There are also exciting new studio laptops for content creators, like the ASUS ZenBook Pro 16X, the Acer Concept D5, and the Lenovo Yoga Slim 7i Pro X. NVIDIA Studio is our platform designed to enhance and accelerate digital artist workflows. It's an end-to-end approach, starting from our GPUs that include dedicated hardware to accelerate ray tracing for gamers and creators, AI features to simplify content creation, high-performance encoders and decoders to accelerate video editing, and CUDA for compute-intensive tasks like image processing and simulation. There are now over 200 NVIDIA Studio accelerated apps. We have also developed our own applications for NVIDIA Studio, including Broadcast for live streaming, Canvas for painting landscapes with AI, and Omniverse for advanced 3D design and collaboration. NVIDIA Studio and RTX laptops deliver a significant performance advantage in ray tracing and
this
AI
keynote, they've actually given a lot of reasons why the Omniverse should exist, which they didn't last time. They just announced that it does.
M1 Max processors, and up to 3 times faster in AI processing
Which is still
unlocking
something
new
Facebook
workflows
or
for artists.
Meta haven't done with the
3D
metaverse.
designers
Why
and
the fuck would
artists
anyone
are the
get involved with
builders of the
metaverse?
next digital frontier.
Mhm.
Vast virtual worlds filled with factories, homes, shops, museums, robots are now being built. Today, a 3D artist typically works sequentially across multiple applications, exporting and importing large files many times along the way. Omniverse was designed to unlock the potential of 3D design and allow creators to collaborate on large interconnected spaces. Omniverse is an open platform connecting the industry's leading 3D tools, including Adobe, Autodesk, and Epic's Unreal Engine, into a shared single environment. And it's fully accelerated by RTX ray tracing, AI, and compute. Over the past year, we have seen a 10 times increase in Omniverse downloads, with 120,000 unique users creating or developing on the platform. Omniverse is the future of 3D content creation and how virtual worlds will be built. And we continue to update Omniverse with new capabilities. Omniverse Cloud has added Simple Share. With one click, users can send an Omniverse scene for others to view. We've added Audio to Emotion, an AI-powered animation feature that generates realistic facial expressions based on just an audio file. Omniverse XR is now available in beta. You can open your photorealistic Omniverse scene and experience it fully immersive in virtual reality. And Omniverse Machinima has been updated to make it easier than ever for 3D artists to create animated shorts.
Where in the world am I?
I'm in the Omniverse.
And check out our Made in Machinima contest. It's in full swing. Create an easy animated short with Omniverse materials, physics, and game assets for a chance to win top-of-the-line RTX Studio laptops. Over the past 20 years, Nvidia and our partners have dedicated ourselves to building the best platform for gaming and creating. Hundreds of millions now count on it to play, work, and learn. RTX has reinvented graphics, and the momentum continues to grow. There are now over 250 games and applications. Gaming laptops are the fastest growing PC category, and Max-Q 4.0 is delivering a new level of power efficiency. These are our most portable, highest performance laptops ever. Massive, interconnected 3D destinations are being built today. NVIDIA Studio and Omniverse are designed to enable collaboration and construction of these virtual worlds. Finally, I want to thank our partners for working so hard alongside us to bring new innovations to the market and helping build this amazing PC ecosystem.
Thank you for watching. We wish you and everyone around the world safety, peace, prosperity, and good health.
I just want to point out the difference in definition in Jensen's leather jacket compared to his face. It's clear where the rendering budget went. Right. I am going to take a quick before we move on. Before we move on to watching the AMD keynote. The also play. Right, found it. Right, let's take a quick pee break. Back in a couple of minutes. What AMD are doing, which is undoubtedly going to be, or probably going to be much more game. That's what they do. A bit of data center with Ryzen and Epic, but generally less esoteric than the majority of that. Hello again. This is apparently the introduction we get to AMD. Just a sign of what is about to be revealed. I hope not, anyway. Alright, let's see what AMD have to say. This was yesterday. Oh, no, actually. When was this? 23rd. So yeah, this was actually yesterday.
Audiences from all over the world, welcome to Computex 2022. After 2 years of pandemics, our lives have changed dramatically in every aspect, for work, study, entertainment, and especially for technologies. Computex 2022, hosted by Teitra, will continue hybrid this year. Our hybrid activities will include an online
available for this one,
called
unfortunately, like they were for Nvidia.
Computex CEO keynotes, Computex Forum and Innovex Forum, and online matchmaking conferences. We are excited that you are joining us from around the world for this highly anticipated Computex AMD CEO keynote. Today, I have the pleasure of introducing Dr. Lisa Su, Chair and CEO of AMD. AMD is the industry's high performance and adaptive computing leader. Under Lisa's leadership, AMD has successfully executed a multi-year strategy with the strongest portfolio of computing.
Under Lisa's leadership, they did not go bankrupt, which was not looking likely, actually,
and delivered industry-leading growth
when she took over.
This is the third occasion that Dr. Lisa Su delivers a keynote at Computex. She will share AMD vision to advance the PC experience through next-generation mobile and desktop PC innovations, combining cutting-edge CPUs, GPUs, and software.
There were rumors in about
AMD and its ecosystem partners will show breakthrough
2015
and
that
leadership
AMD
for gamers
was going to be bought out by Samsung.
We can't wait
Obviously,
for
that didn't
exciting
happen.
news that Lisa is about to bring. So please,
I'm not
let's
sure
welcome
they would.
Dr. Lisa Su.
Intel would allow the company to cease existing because of where it would leave the weird x86 licensing situation, but I'm not sure they would like it to be bought by Samsung either.
Welcome, and thank you for joining us today. I also want to thank Teitra for the invitation to keynote Computex 2022, and Chairman Wang for the very kind introduction. Every year I look forward to Computex as the opportunity for our industry to gather in Taiwan and highlight the deep partnerships throughout the ecosystem and our work together to shape the future. From system design and manufacturing to motherboards, graphics cards, and other critical components like memory and storage, our partners in Taiwan play a critical role helping AMD push the envelope in high-performance computing. This is the most exciting time for the semiconductor industry. Whether you're talking about cloud, supercomputing, 5G, AI, or intelligent end devices, high-performance and adaptive computing solutions are playing a larger and larger role in every aspect of our daily lives. And we see this trend only accelerating in the coming years. We recently closed our acquisition of Xilinx, the largest semiconductor transaction in history. And AMD now has the broadest portfolio of leadership compute engines in the industry, building on our high-performance CPUs and GPUs with the industry-leading FPGAs and adaptive SoCs. Now, AMD is all about pushing the envelope on technology. Wherever our partners have a need for more computing capability, you will find AMD. And you can see our products and technologies everywhere, from PCs to game consoles, smartphones, the cloud, and now industrial and telecom as well. Today, though, is all about our next generation of PC products for gamers, creators, and enthusiasts. Now, as we've seen over the last several years, the PC has never been a more essential part of how we live, work, and play. With 349 million PCs shipped in 2021 and more than 900 million shipped in the last 3 years. At AMD, we're all about building the best. Today, we're going to focus on the best in PCs, including new leadership ultra-thin commercial and gaming notebooks, and new details on our next generation Ryzen desktop processors and platforms. Let's start with the latest in ultra-thin notebooks powered by our Ryzen 6000 processors.
Oh yeah, that reminds me. We watched an hour of Nvidia earlier. They didn't actually announce anything. We know that there's 2 generations of graphics card coming up. Possibly in June. Possibly July. Maybe September. So it's going to be in the next few months that Nvidia are releasing the 4000 series. The closest they got to that, we're talking about Hopper, the H100, which isn't new. Like, it's a new architecture, but in itself, it's not a new product. So, yeah, that's a bit weird. I was expecting something about Ada. See, they didn't mention the architecture Ada or Lovelace. I don't know which one they're going with. I've heard it called both Ada and Lovelace. I've also heard it called Ada Lovelace, which iron name. They didn't call the 2000 series the Alan Turing. Called it Turing. Anyway, point being, we might actually get an announcement of something in here that we did not get. Video. And as far as I know, there's no Computex showing from Intel at all.
Here's Jason Banta, General Manager of our OEM PC business.
Thank you, Lisa. At CES earlier this year, we brought you the incredible Ryzen 6000 Mobile, powered by the Zen 3 Plus CPU core, RDNA 2 graphics, and 6nm TSMC technology. Ryzen 6000 also brought an entirely new notebook platform, delivering DDR5, PCIe Gen 4, and USB 4 in the most premium notebooks. We promised leadership, performance per watt, battery life, and graphics performance in Windows 11. The initial reviews were a resounding reflection that we delivered on our promises. The Asus G14 was consistently awarded for its combination of gaming performance, innovative form factor, and exceptional battery life. And 72 Ryzen 6000-based systems have either launched or been announced to date. But our Ryzen 6000 portfolio is only just beginning. Ryzen 6000 will establish leadership in additional segments, including ultra-thin consumer and commercial enterprise notebooks.
These are interesting because these are like
our goal
the Steam
with
Deck
Ryzen 6000
kind of
ultra-thin
thing.
is to partner on notebooks that are ready to work,
like they're the
create,
same GPU
collaborate,
architecture as
and
the
even
Steam
game
Deck.
on the go. Just
with
like our
updated
gaming notebooks,
CPUs.
we want our ultra-thins to
Steam
offer
Deck
the
still on
perfect balance
Ryzen
between
3000.
performance and mobility. With the incredible efficiency delivered by Zen 3 Plus, our U-series processors enable some of the thinnest, lightest, highest performing ultra-mobile PCs in the market, outperforming our competition's P-series. By combining our RDNA 2 graphics core, DDR5 memory, and Fidelity FX, we can enable new experiences on the thinnest systems in the market today. The recently launched ZenBook 13S OLED is only 14.9 millimeters thick and weighs only 2.2 pounds. This slim, sleek system can easily run Godfall 1080p at over 60 frames per second. The recently launched Yoga Slim 7 Pro X delivers discrete level gaming performance in a chassis less than 16 millimeters thick. We partnered with PC OEMs on some of the most exciting premium ultra-thin notebooks launching this year. Now, in the commercial segment, Ryzen 6000 delivers the ultimate productivity and collaboration experience to the new, increasingly hybrid workforce. The way we work and communicate has fundamentally changed in the past few years. The amount of time spent on video collaboration has more than doubled in the past year. Over 70% of workers want flexibility between office and remote. Yet the average system today is over 4 years old, leaving workers ill-equipped for this transition to hybrid.
True.
Our innovative partner
My work
platforms
laptop is
based on
shit.
Ryzen 6000 deliver on the full
dual-core
set of
Celeron.
hybrid workforce needs. Exclusive platforms like the all-new ThinkPad
had
Z
it cut
series
off in
and the
parents'
award-winning EliteBook line
Generally had it cut off in parents' evenings because it didn't have the RAM to handle both Excel with data on it and also the video conferencing, which is all in browser. Yeah. It's... While it's not a laptop I would have chosen, we don't have a say on that, so there needs to be a... Software needs to work in the hardware ecosystem that's available, not in the one that you would want. Fortunate.
seamlessly blend collaboration, productivity, and mobility. Over 60 commercial notebooks will launch this year based on Ryzen, an increase of over 25% year on year. Ryzen Pro has become synonymous with performance on productivity applications. The latest Ryzen Pro commercial notebooks outperform competitive processors by up to 17% on combined Microsoft Office and Teams productivity. The efficiency optimization enable continuous collaboration from the office, the coffee shop, or the couch. Ryzen 6000 delivers a 45% battery life advantage on Microsoft Teams when compared to notebooks powered by a comparable competitive mobile processor. Ryzen 6000 Pro has also taken the commercial battery life crown based on third-party analysis. The HP EliteBook 865 G9 ranks as the #1 laptop in the world on the Mobile Mark 2018 benchmark with 26.1 hours of mixed usage battery life. While Ryzen is known for premium notebooks, we want to ensure that the modern mainstream market experiences Ryzen innovations as well. During the past few years, millions of people have found their way back to the PC. It has become an everyday device for everyone. But most mainstream notebooks are not ready to deliver a full-featured, responsive Windows 11 or Chromebook experience. Today, we are announcing a new APU codenamed Mendocino that will launch in the second half of this year. Mendocino is ideal for do-it-all Windows 11 notebooks and Chromebooks between $399 and $599 US.
Zen 2.
Built on the same low-power, high-performance 6nm technology.
Zen 2. So the 3000 series. 4-core 8 threads. So this is the same CPU that's in the Steam Deck. 6nm though. As opposed to 7 that is most 3000 series. Interesting. So 4-core 8 thread Zen 2 RDNA 2. This is literally what's in the Steam Deck.
As our award-winning Ryzen 6000 mobile product family, Mendocino offers up to a quad-core 8-thread Zen 2 CPU, true RDNA 2 graphics, LPDDR5 memory, and cutting-edge video codecs to enable seamless collaboration across Zoom, Teams, and Google Meet. The number of systems announced using Ryzen continues to grow rapidly. Over 72 Ryzen 6000 notebooks have been announced by OEMs thus far in 2022, and the options will continue to grow throughout the year. The full Ryzen mobile portfolio includes 50 gaming systems, 90 ultra-thin systems, and 60 commercial systems shipping during this year. This portfolio brings more options to enjoy the superior performance, exceptional mobility, and captivating experiences delivered by Ryzen. Now let me hand it off to Frank Azor to talk to you about the latest on AMD Advantage.
Frank Azor, wasn't he the one who boasted in September 2020 when Nvidia 3000 series was released about how bad the supply issues were, and then personally guaranteed that everyone who wanted an AMD GPU would be able to get one when they were released a month afterwards? And then their supply was even worse. They sent like 10 to the entirety of Europe or something ridiculous like that, to the point where he couldn't even get his own hands on a 6800 XT and had to settle for a 6800. Is it that Frank Azor? I'm pretty sure it was him.
Thanks, Jason. Imagine a gaming computer where every core component is designed to work seamlessly with one another, where every performance and
Imagine being able to
efficiency
buy an
metric
AMD
is optimized
GPU.
in the CPU and
Amazing.
GPU since their inception.
But I'm
for the
glad their
purpose of
supply
delivering to
issues are
you
fine, and
the
it's just our fault we
absolute
can't buy
best
one.
computing experience technologically possible. That is our vision for the future of gaming at AMD. About a year ago at Computex, we announced the AMD Advantage framework. These solutions feature AMD high-performance components, including our family of exclusive smart technologies. AMD Advantage laptops are developed to follow stringent design guidelines and processes to deliver systems with state-of-the-art performance, beautiful high refresh rate displays, fast load times, great battery life, and so much more. Our mission with AMD Advantage systems is to raise the bar of what defines the industry's best gaming laptops. And it starts with our smart technologies, where AMD CPUs and GPUs work cohesively together to help eliminate system bottlenecks with technologies like smart access memory, while at the same time delivering power.
As a reminder, smart access memory is part of the PCIe standard. They did try, sneakily, to say at one point that you needed a Ryzen 5000 series and a Radeon 6000 series, and they would talk nicely via a super secret interconnect that ended up just being the PCIe bus. That is actually known as resizable BAR and is now available on any real. Actually, Azor is bullshitting it.
Where and when it's needed most with SmartShift Max. AMD Smart Access Graphics intelligently optimizes your system for maximum performance and efficiency. And for delivering outstanding gaming on battery sessions, we've created SmartShift Eco. Today, I'm excited to announce our next smart technology. Smart Access Storage gets you out of the load screen and into your gameplay faster than ever. Traditional game loading takes a significant amount of compute power to decompress the game's data, requiring the CPU to do the decompression and data transfer, which introduces latency and takes up considerable system resources. To help bypass these bottlenecks, AMD's created Smart Access Storage, a suite of technologies supporting Microsoft Direct Storage that utilizes smart access memory along with new AMD platform technologies and Radeon GPU asset decompression to improve.
Wait, say that again.
Suite of technologies supporting to decompress the game's data, requiring the CPU to do the decompression and data transfer, which introduces latency and takes up considerable system resources. To help bypass these bottlenecks, AMD's created Smart Access Storage, a suite of technologies supporting Microsoft Direct Storage that utilizes smart access memory along with new AMD platform technologies and Radeon GPU asset decompression to improve both game load times and texture streaming.
So, Smart Access Storage is Microsoft's Direct Storage. The PCIe standard resizable BIR, where you're not limited to 256 megs of data access at a time. You can access more memory than that. Chunks. And the only thing that actually seems AMD's in this is the decompression algorithm they're using, which seems to be GPU based. Okay. This is a thing that gets me. That AMD Smart Access Storage is just AMD sticking their branding on two other people's technologies. Like, one of them is the PCIe standard, the other one is part of Microsoft Windows. Like, am I gonna, if I buy a AMD graphics card and I stick it in my PC now, will I actually have AMD Smart Access Storage, given it won't have access to the stuff that's actually Microsoft? Seems unlikely.
We're so excited about this new technology. Stay tuned for more news on Smart Access Storage in the coming months. Now, let's talk about some of the awesome AMD Advantage gaming laptops we have coming to market, built with the latest Ryzen 6000 series processors, the latest Radeon 6000M and S series graphics, and AMD's smart technologies.
I like how he said M and
mentioned
S
earlier, the
and not
first
S
AMD
and
Advantage
M.
solution we launched this year was a 14-inch ROG Zephyrus G14.
These aren't just
At only
innuendos.
18.5 millimeters thin, it's quickly become one of the industry's favorite gaming laptops. The system's already available at most retailers and e-tailers worldwide for you to experience yourself, so go check it out. For gamers looking for a desktop-like experience in a gaming laptop, the Alienware M17 R5 offers supreme performance on a beautiful 17-inch low blue light emitting display with up to 500 nits of brightness, featuring
that's
Dolby
bright.
Vision and refresh rates up to 4K at.
Okay, caveat. It's bright for SDR. It is not bright for 8. Not use this. I know I have a 400 nits HDR panel. Not get used for HDR. It did not get used for HDR in Windows when I could, because 400 nits is not good enough for HDR. The brightness isn't there. In order to get the contrast ratio, you have to turn everything down, all the brightness down. It is not a good experience. I personally would, if I wanted HDR, I would aim for 1,000 nits at least. Yeah, don't use 400. Just enjoy the nice. I was gonna say enjoy the nice brightness, just as my screen face lit up. Enjoy the very bright SDR content, which will be good
at 120 hertz. Lenovo recently announced the Legion Slim 7. This is the thinnest AMD Advantage laptop yet, offering 100 frames per second gaming performance in a 16-inch laptop that's just 17 millimeters thin. The system features powerful and efficient AMD processors and graphics, and a massive battery capacity up to 100 watt-hours. So much performance and battery in such a thin and light form factor makes the system an incredible engineering achievement. For performance-demanding gamers, the new Lenovo Legion 7 AMD Advantage Edition gaming laptop features new WASD keys equipped with precise force sensor technology. This technology allows players to scale their input through different levels of pressure applied to their keyboard.
I've been wanting an analog
Imagine being able to control the speed your character moves in-game based on how hard or soft you press on the WASD keys.
It'd be even better with a mechanical keyboard
Force
where you've
sensor
got a
technology
decent travel
literally adds
distance.
New dimensions to how you game. Meta MacBook and Origin are two of our first AMD Advantage system integrator designs. These systems will be available starting this summer on OriginPC.com and JD.com, and they'll come with the latest AMD Ryzen 6000 series processors and Radeon graphics, and will each be enabled with the family of AMD smart technologies. For gamers who want to play unplugged, the new Omen 16 by HP is the first system to launch with AMD Smart Shift Eco enabled, giving you up to 60% longer gaming time on battery in a game like League of Legends at 1080p. This system also features Omen Tempest cooling technology, which keeps your system cool and quiet, along with an iSafe low blue light certified display.
HP really come up with a
finally,
name for a fan.
I'm excited to announce that this summer, Corsair will be launching their first ever gaming and streaming laptop exclusively with AMD Advantage. The Corsair Voyager features the latest Ryzen processors and Radeon graphics. It's enabled with the entire family of smart technologies, and it features a 16-inch FreeSync Premium 240 Hz WQHD Plus display. Voyager is the first laptop ever designed to be a truly mobile streaming solution. It features an integrated 10-key streaming command center, powered by Elgato's popular Stream Deck software, and a 1080p high-fidelity webcam
All right, that's what makes it a stream PC. They've put Apple's Touch Bar at the front and called it Stream Deck. I mean, they're Corsair. They own Elgato. Makes sense. I do like the fucking massive touchpad though. That's nice.
Powered by the Elgato integrated camera hub software, allowing you to do things like dial in your field of view or change video inputs, putting studio level controls at your fingertips.
On the minus side, I guess it's a laptop. You'd have to do all this in software. You hardware, like a DSLR or I just really don't have a good experience with Elgato software. I'm not sure building into the laptop is going to be the best user experience. Mind you, Corsair, I do like most of Corsair's hardware. There's power supply and stuff like that. Really, the Elgato side of things, I just have a really bad experience with both hardware and software. It's more Apple than it is Elgato, so.
Equipped with Corsair's DDR5 memory and smart technologies like Smart Shift Max, users can automatically unlock the full potential of this laptop, whether gaming or streaming. We're very excited to have Corsair Voyager join the award-winning AMD Advantage portfolio of laptops. Voyager is available this summer from Corsair and retail partners worldwide, including customizable versions from Origin PC. Thank you for your time today. Let me hand it back over to Lisa.
Thank you, Frank and Jason. We're very excited about bringing together the...
I know she said Frank and Jason, but it sounded like she said Frank and Jason, which I'm now imagining a body horror hybrid of the two.
Power of Ryzen, Radeon, and AMD software to build the best in ultra-thin commercial and gaming notebooks. Now, you all know that at AMD, we're always working on what's next. So let's close with a preview of what comes next for desktop PCs. Today, tens of millions of gamers, creators, and PC enthusiasts use AMD Ryzen processors in the AM4 platform. AM4 motherboards were first introduced in 2016. Almost 6 years later, we've now shipped...
Yeah, imagine that. You forget that AM4 has been around longer than Ryzen. The first processors people were putting into these motherboards were excavator-based APUs. They were not even first generation Ryzen. And think about that. We have 2016 excavator APUs, low power, very low performance. We have people who theoretically could have got a motherboard for that very low end, bottom tier crap and put a 5950X in. I wouldn't. If I were buying an excavator APU from 2016, I would have put it in a cheap motherboard. I wouldn't. How would you get a very, very, very low end cheap in a motherboard that's more expensive? In that, would you trust all the voltage regulator or the power delivery that is designed for a low end APU to a 16 core behemoth? Would match you requirements what it's going to sit in, because it's not worth the potential damage. And AMD have done this before, like with the FX 9590 is, oh shit, our bulldozer architecture doesn't perform very well, we're losing to i3s and i5s. I know, let's clock the shit out of it, make it 300 watts. Let's ship it with a water cooler, because that's what's needed to cool the fucking thing. Let's accidentally make it phase change. No, let's not do that. Yeah, I wouldn't put a 2016 core in a motherboard I bought in, even if the socket fits, because the rest is up to the task. But that's why people like Buildzoid are good, and Bauer, they both very good content motherboards, and particularly power delivery. Always worth watching.
Shipped nearly 70 million AM4 CPUs, spanning more than 125 unique processors, 5 different architectures, and 4 process technology nodes. Ecosystem support for AM4 has been amazing, with our partners introducing more than 500 unique AM4 motherboards, and AM4 is still going strong. Just last month, we launched the Ryzen 7 5800X3D, the world's first desktop CPU with 3D stacked chiplets. It plugs into existing AM4 motherboards and delivers an average 15% boost in gaming performance over the 5800X. This type of performance improvement has typically only been possible with the introduction of a new CPU architecture. And as the reviews have highlighted, if you want the best PC gaming processor today, it's the 5800X3D in the AM4 platform. And when you look at the numbers, compared to the best gaming processor from the competition, the 5800X3D wins across a broad range of games. It is the world's fastest gaming CPU, and importantly, it delivers that leadership performance.
It's worth pointing out. I'm going to point out a few things. First, when she says the competition, she's comparing this CPU, $400, something like that, with the Intel i9-12900K, which prior to this was the best gaming CPU. That is about $800. It's about double the price. It also is an 8-core, it's 8 P cores, 8 E cores for a total of 24 threads. Let's be real, the 12900K is trying to compete with the 5950X, which is also an extremely good gaming processor. That was, I believe, the best. But before Alder Lake was released, I think the 5950X was the best gaming CPU. They are literally leapfrogging each other at the moment. It's great. So, but yeah, both the 5950X and the 12900K are obviously workstation CPU. They are very good at highly multi-threaded, multi-activities. If I bought a 3950X mainly so that I could play a game on 8 and encode stream on the other 8 cores, let the OS that mix. But that was the idea. And if I had a 12900K, what would happen is the game would be just E cores, the stream would be E cores, essentially not independent. It would be good. And a similar thing would happen on the 5950X. What I'm getting at is that these are both CPUs that are far too expensive for anyone to be seriously buying just as a gaming CPU. Like, the 5800X3D is the upper limit of what I would pay just for gaming. Even if the 5800X3D were not better, the other two, which it is most of the time. Not on Linux, which not sure. But yeah, they're ones that are really meant for workstation tasks that just happen to be extreme gaming, which is why I would never talk about the value of the 12900K compared to this. For gaming, yes, it is shit, but that's not really what it's meant. Same with the 5950. Same with the 3950 for it. Honestly, if I were just gaming, I would probably just get a 5600 or a 12 I probably wouldn't even get an i5 12600. I would probably get the 12400. I think for the gaming performance you get versus the price, it's probably the best value. The 5600 X was good, but it was expensive, given it was the lowest end they had for a good time. I know they've released lower end now, but a bit expensive for the performance. Same with the 12600 and the 12600K, the 12600F. They're good, and you do get the E-cores with that as well, which you don't with the 12400. Just, I don't think the value is there if I were just gaming. If you're doing other things at the same time, if you're doing content creation, you're doing any kind of activity, if you're rendering videos or anything like that, you probably. Anyway, I've ranted.
Performance
Long
while
enough.
using significantly less power. Now, while AM4 is a great platform that will continue for many years to come, building the best PCs is always about pushing the envelope. And
isn't it funny though, actually, in retrospect, just thinking about what I was just talking about, we're now at the point where the absolute best CPU for gaming is AMD, but the best value option is Intel. Isn't it funny how the tables have completely turned? The absolute best, money no object, go AMD. Want something on a budget that's good value for money, go Intel. Completely the opposite to what it was even 2-3 years ago.
And for AMD, we do this by combining our multi-generational CPU core roadmap with advanced manufacturing process nodes and leadership packaging technologies. Today, I'm really excited to share more about the next major step in our roadmap that extends our leadership in desktop PCs. Our next generation Ryzen 7000 desktop CPUs combine our new Zen 4 core in 5nm process technology with the all-new socket AM5 platform to bring more performance, more features, and more capability to desktop PCs. And it all starts with our Zen 4 core. We designed Zen 4 to deliver significant performance and performance per watt advances over our already industry-leading Zen 3 core. We doubled the L2 cache to 1 megabyte per core for higher throughput. We've also increased the clock speeds on Zen 4 to run significantly above 5 gigahertz. And with higher IPC and faster clock speeds, we expect Zen 4 CPUs to deliver more than 15% higher single-threaded performance compared to the prior generation. We've also added instructions for hardware-accelerated AI workloads like neural networks and machine learning. Now, for the first time, let me show you our Ryzen 7000. As you can see, Ryzen 7000 CPUs include up to 2 core chiplets, each with 8 Zen 4 cores, built on an optimized version of TSMC's high-performance 5nm process technology.
16 cores again.
The larger chiplet is an all-new 6nm I/O die designed for Ryzen 7000. We added RDNA 2 graphics, bringing integrated graphics capabilities into our Ryzen Enthusiast desktop CPUs for the first time.
Wow. Yay.
And we've also made significant advances in power management and added support for the latest.
That's interesting. You can now have QuickSync on an AMD CPU. Well, it won't be cool.
Memory and I/O technologies like DDR5 and PCI Express 5. To tell you more about our new AM5 desktop platform, here's the general manager of our desktop business, David McAfee.
Thanks, Lisa. Beyond the processor itself, one of the most exciting aspects of this new product family is the transition to the AM5 platform ecosystem. As Lisa mentioned, AM4 was an incredible platform with longevity and capability beyond what we even imagined it would be when it was first introduced. As we approached the design of AM5, our philosophy followed many of the same principles. We wanted to create a platform designed for flexibility and built for the future, one that maximized the capability and performance of our processors, and one that incorporated modern I/O and interfaces that will define the next generation of enthusiast desktop PCs. To that end, our new AM5 platform will lead the industry in capability for the most demanding enthusiast PC builds. That starts with an all-new socket and a transition from micro PGA to an LGA socket to.
I'm gonna take a quick pee break. You really need to be. I've noticed I've been getting up to go get a drink constantly, particularly throughout the Nvidia one, and it's a bit catching up with me now. Let's put some music on and let's finish. We've got about just 10 minutes left. Okay, we'll watch the final bits after I have to eat, and go get a drink as well. That's not an end of the cycle stuff. Hello again. I have returned. And I have returned with Rose.
Socket and a transition from micro PGA to an LGA capability for the most demanding enthusiast PC builds. That starts with an all-new socket and a transition from micro PGA to an LGA socket to drive more power and greater signal integrity for all of those high-speed IOs. Pair that with an expansion to new processor infrastructure groups all the way up to 170 watts TDP to take advantage of the performance per watt efficiency of leading-edge process technology nodes, unlocking even more all-core performance. It incorporates next-generation I/O capabilities, including dual-channel DDR5 memory and the capability to drive the most PCI Gen 5 lanes from the processor socket in the industry. And last but not least, over the past several years, we've developed a robust cooler ecosystem for AM4 platforms, supporting a wide range of passive, air, and liquid coolers in all shapes and sizes and price range. And I'm happy to say that as we make this transition, our new AM5 socket will be compatible with existing AM4 coolers. When you look at AM5's I/O capabilities, we've made many enhancements, like enabling 24 PCI lanes capable of Gen 5 speed connected directly.
All right, let's take the good with the bad, the rough with the smooth here. On Zen 2, Zen Plus, Zen 2, and Zen 3, APU ate into the PCIe lanes, you guys. One of the reasons that they... With Intel, you buy a 12900K. It has integrated graphics on it. You get the advertised number of PCIe lanes. NVMe or whatever sound card, why not go crazy? You have all that attached to it. And you divvy up your lane. And it you don't get many PCIe lanes. It's a bit shit. Intel have always skimped with that on the mainstream platform, right? But you get what you get. With AMD APUs prior to this generation, PCIe connectivity was divvied up between the integrated main system. That meant that if you bought an R5 or even R7 APU, what's it, 56 AMD 56. Yes, that is a thing that exists. All right, let's say you get one of those and it's the integrated part of that would not leave many PCIe lanes for the rest of the system. So if you were then to put an external graphics card in it, you would be leaving performance on the table that you would not be leaving behind if you just got the normal 5600X without the G. That's always been the downside, because a lot of people, when they buy APs like this, do it because they can't afford to buy the entire PC at once, right? It's a fucking big expense to buy all that at once. So a lot of what makes sense for a lot of people is to buy an APU with integrated graphics, play on that for a bit, enjoy the 720p 30 experience, and save up, and then buy a better graphics card than they could have done if they just went all out and bought it at once. That's one of the things. And unfortunately, the way that the APU worked in previous generations of Ryzen meant that that wasn't a great thing to do long term. This, at least, is promising because you get all your advertised 24 lanes of PCIe in addition to whatever's being used internally for the in fact, it probably is. I wonder if it's any connectivity, given it's part of that second or third I/O die. They probably got around that limitation by putting it inside that 6nm die. So that actually made me think of something interesting. The chipset that AMD use is typically that I/O die. Like, the chipset in my motherboard is literally an I/O die that didn't find its way into a CPU. It's on a motherboard instead. Does that mean that the next generation motherboards are going to have integrated graphics on the motherboard? Could you crossfire them? Is that a thing? Probably not, but there's thinking about. Oh yeah, and the negative, the issue I have. All right, let's go on a journey. In 2011, bought my first major gaming PC. It was an i7 3960X Extreme Edition. Sandy Bridge. 2 GTX 580s and SLI. The reason I'm going on about this is because the iGen 2, I was using that until 2019, by the way. I upgraded. So in 2011, 2012 is December, January time. I had 40. Sandy Bridge E desktop 36 quarter 4 2011. So it was brand new. It was brand new when I bought it. It was, this says a lot about how the pound and the dollar were at the time. It was about £700. £700. Which was about $1,000 at the time. And £700, about what you spent on something. 6 cores, 12 threads. Bad for 7 years ago now. 130 watts. Well, at the time, they've surpassed that. Intel have. Down the R3. I think I used 133. Which, if you assume these are, that's 3200. 2160. Okay. Quite tight. Don't expect me to do mental maths right now. Now I'm tired. Quad channel memory. That was good. People say, oh, you don't need quad channel memory for... Oh, I am an actual guy. Oh, white I am. I'm just reflecting this back at you. But no, this is... Oh, you don't need quad channel memory if you're just gaming. You don't need six cores for gaming. I mean, that was true actually at the time. That was true back in 2011. But actually, when DDR3 2133, when that was the shit tier of DDR4 equivalent, you know, having more memory bandwidth did help. Definitely help. Having 6 cores. There are people who were on the 600, the 2600K, who were having difficulties maintaining 60 FPS when I wasn't. Eventually, 6 cores became not only used, but mainstream. So, I'm glad I went with this because this CPU lasted me a decade. This CPU kept on going. And didn't only keep on going, it kept on going well. And actually, yeah, it was only PCIe Gen 2. I had 40 lanes of PCIe Gen 2. I had 2 graphics cards, both running in by 16. That is already 32 lanes. That is more. That already is more lanes than this Ryzen CPU. Right? I had an M.2 plugged into a PCIe slot through a card because it predated the M.2 standard. That's another 4 lanes. Now on 36. I then had a sound card that was like no more than 40. But that would have brought me about up to 40. So I actually, this is the Extreme Edition platform. I actually used all 40 lanes. It wasn't some esoteric thing that Workstation uses my word. As a gamer, I didn't even stream back then. I was just a gamer. I used all 40 lanes of PCIe. It's not difficult to do. And Intel Arc Intel 12900. Let's see how many lanes this gives. See how many PCIe lanes we get. Oh, that's cool. 20. And it can't just say 20. It's got to have, you got to do fucking algebra to work out how you could connect the things I had. Whereas before I just had 40 lanes of PCIe 2. So yeah, that's where I stand. If I'm on a 16 core processor, which I am, I've gone from 6 cores back in 2011 to 16 in 2022, 11 years later. I don't like to see downgrades. I think things, to quote a certain particle physicist, should only get better. I know it's PCIe 5 versus 2. So that is 2 to 3 is a doubling, 3 to 4 is doubling, 4 to 5 is doubling. It's 2 times 2 is 4. So it's 16 times as fast per lane. Which, okay. That does enter into the equation. But I would like to see this go back to the dizzying heights that we saw in 2011. I don't also like the fact that you have to go up to Threadripper. Threadripper doesn't exist anymore, by the way. Not unless AMD bring it back. The most recent Threadripper revision was the 3000 series. Haven't done anything 5000 series. And they're announcing the 7000 series now without any news. 5003. I do not actually expect to see a Threadripper this generation. And possibly next. Possibly ever. Who knows? Maybe it will take Intel to make an Alder Lake X for them to bother competing. But yeah, that's my concern. I would like to see the level of connectivity. Also, I don't necessarily want to see it gated off to people who want 24 cores. If you want more than 24 lanes of PCIe on Ryzen, you have to get a 24 core minimum. Like that's the 3960X. And it goes up beyond that, 32, 48, whatever. I used all these PCIe lanes with a 6 core. That's equivalent to like a 5600X now. I used all this with the equivalent of a Ryzen 1 1600X, right? I don't see the logic in gating these features off. Like, how much storage do you want? How much M.2 do you want? Do you want M.2 RAID? Do you want a RAID SSDs? Do you want a RAID 1 SSD? Do you want to build a NAS? Do you want to build a media storage? I had like 11 USBs on the back of my old PC. Oh, I never had to buy a hub. I've got a hub now. Need it. Don't have enough USBs on the motherboard. I needed to get a hub. I've never done that. I had 11 USBs. Why the fuck would... I also have to be careful of which if I'm using my wireless Xbox controller with a dongle, I'd be careful which USB I'm plugging into, because if I have a couple of things plugged into the one same USB port on here, I can't power it because power is shared between the current is shared. Kirchhoff's first law. I never had to worry about that with Intel from 2011. All of my USBs could handle the sufficient power delivery and current to all of my devices. Never had to worry about that. I do now. So in some ways, we have gone backwards. And again, the CPU, brilliant. 16 core for £700, the same price from my perspective as the Intel Extreme Edition. 6 cores, the 60 cores. That's great. That's progress. The platform, I feel, has not kept up. And I would like the I would like, if you're not going to have a Threadripper, give me 40 PCI Aliens on. Especially now M.2. Now people are putting their entire storage on their motherboard, their PCIe bus. Same with their graphics card. I think that's a thing we need to go back to. This is better than Intel. Intel is shit. Intel has been shit for PCIe on their mainstream platform for a long time. They made up for it with their enthusiast. Now neither company is offering an enthusiast, which is a problem. Back in the day, back for Haswell, people got 5820K. A very popular, technically a workstation. A lot of gamers bought a 5820K. You got your 6 cores. Well, got the expansion and big deal. And I would like to see it back.
To the socket to power the fastest storage and graphics solutions in the industry. We now support up to 14 super speed USB ports, including support for 20 gigabit per second speed and USB Type-C.
I would like to see them on the back of.
We know that connectivity is critical to the.
Can we redesign motherboards? Why is all the I/O at the back? GPU should have their I/O at the back because it can. Although actually, VR these days have it on both. What's the point of having 14 USBs on the back? I have a USB Type-C on the back of my motherboard. I cannot find that when I'm fumbling around. The front of the motherboard needs some. It's so tiny. It's hard enough to find USB A's on the back, let alone USB-C. All that I/O needs to be on the front. I have no fucking clue how you would organize case and motherboard designers to all come together to allow that. It needs to. A lot of PC designers, the fact that this is how it happened to be in the 80s, and we just have been fudging and bodging the standard as time goes on, rather than thinking, have we designed this the way it should be, or have we designed it the way it is? We need to, as a species, come together and redesign cases and motherboard. Okay, maybe.
Enthusiast motherboard user, and AM5 includes support for Wi-Fi 6E for blazing fast wireless connectivity, as well as 4 independent display outputs connected to the integrated RDNA2 graphics engine. In addition to all of that I/O directly connected to the socket, the new.
Okay, I see that. I see the value of that. I've got 4 monitors now. They're all plugged into my R9. Not connected to R9 anything. They're connected to my 3090. If I were just using this as a productivity machine, I wouldn't want to lose the ability to watch Netflix, YouTube, Twitch, up there, have Zoom, a spreadsheet, Word document, all of this stuff simultaneously. I don't game on my 4 monitors. I game on 1 monitor. I have chat on that. I have Discord on that. I have whatever. I have this so that I can have a full screen game and enjoy stuff as it's happening. When I'm cooking, I move Twitch or whatever to that screen up there and I enjoy that. These aren't things that would require a graphics card. So I like the idea of having all of these monitors plugged straight into the motherboard so that if I were just doing productivity, which this would be more than capable of, right? This would be very capable of driving 4 panels simultaneously off of integrated graphics. Wouldn't be everything. So yeah, I like the fact that this is a thing.
New 600 series chipsets bring a host of expansion options to the platform to meet the needs of even the most demanding users. Now, beyond the core platform,
which is me, I'm very demanding.
Socket AM5 ecosystem also features an all-new SVI3 power infrastructure. This brings multiple advantages to the platform, such as support for additional power phases, for that higher power delivery into the motherboard, fine-grained power control, and significantly faster voltage response capabilities. Our AM5 motherboard family will feature
What's the
three levels
TDP of the
boards with
7950X going to
different
be?
features targeting different segments of the desktop market. At the very top of the stack, we have our
The voltage, the fast voltage changing. Yeah, you want that. You want it to go from an idle state to an in use state and back again very quickly for efficiency, for low power use. You don't, if this has got really high TDP. Let's say, I think Gamers Nexus managed to measure about 200 watts from a 12900K. Scary, but let's say 200 watts. You don't want it running at 200 watts all the time. If you have a short bursty workload, you want it to boost up to that for a very short period of time and then go back down as soon as it's not done. You don't want it to hang up there for longer than you need. So I'm hoping that's where this is going and not, let's outpower the 12900K and take the performance crown by brute force. And that's where the graphics card, right? You look at the head-to-head between the 3090 Ti and the 6950 XE. That's a lot of power between them.
our X670
They're not even
Extreme
inefficient
motherboards. These boards
architectures.
deliver
They're
the
just
best of the best across all aspects
ridiculously
of
highly
what the
clocked.
most demanding enthusiasts crave. PCI 5, dual-channel DDR5 memory with the most extreme overclocking headroom and the most power phases to push the limits of performance and overclock. PCI 5, dual-channel DDR5 memory with the most extreme
Oh, you're talking about
overclocking
memory.
headroom
Okay, fair enough.
and the most power
I
phases.
say the whole point of Ryzen's entire thing, way back from Generation 1 with XFR, that it overclocks itself and boosts to it. There's actually no point in really overclocking Ryzen. I did for a bit. I experimented. I didn't actually. I overclocked my 3950X to see what I could get out of it. I managed to get a 4.2 gigahertz all core. My temperatures were over the 90s and I was hitting the power limit. Yeah. When I run it also, it's 3.9, 4.0 gigahertz, and then I get about 4.3. 44.7 advertised, but no one gets what they advertise on Zen. Fortunately, the rest of the CPU makes up for. Yeah. What was I gonna say? It overclocks itself. There is really no point in it. It doesn't have the hard limit that hard TG. The Intel does, or it would be fully in. Oh, this is all on an NHD air cooler, but it's so yeah. I changed my CPU, I believe, for my my cooler for my old one. I used to have a Corsair H110, but the pump died. Fortunate. I can't compare how the NHD 15 compared to that, but on my Intel CPU, which already pointed out that it had a 130 watt P, and well, it was 0.45 gigahertz, something like that. But yeah, the temperatures I got from that same. So I'm going to just approximately judge the NHD 15 roughly equivalent to 280 mil. Bad. Not bad going. Mind you, it is a kilogram of. So.
Is to push the limits of performance and overclocking. Next, the X670 AM5 platform delivers the goods for the bulk of Ryzen enthusiasts and their gaming builds. PCI 5 to at least one of the M.2 slots, as well as the primary graphics slot on many boards, as well as very strong memory overclocking and CPU power deliveries on the board. And finally,
all right, so this one, not the extreme one, the X570, is that X5?
well,
X670, sorry. So it's like, this is PCIe 5 Everett, great. If you have anything, I have one M.2 that is PCIe 4. The other one's PCIe 3. Presumably the most extreme SSD 5 going forwards, but again, I don't know if I'm really bottlenecked by the PCIe 4 slot. That interface doesn't seem to be the limit. It seems, but we'll see going forward. That's likely to change. But if it were likely to change, you could be drawing more than 4 lanes. Like these M.2s are 4 lanes of PCI. You could make them 8 lane if you really needed the bandwidth. But they don't. Which implies to me the flash and the controller are what's limiting it, not the PCI interface. Yes. This one here, Socket AM5 X670, this seems to be equivalent to what Intel are doing with the weird PCIe setup that we just looked at with the 12900K.
as the primary graphics slot on many boards, as well as very strong memory overclocking and CPU power deliveries on the board. And finally, our B650 boards.
Actually, we'll go back to my rant earlier, about PCIe's. I would actually not mind if they don't want to do Threadripper. If they really don't want to do Threadripper, if they want to say, you know what? If you want all this connectivity and you want all these extra cores, then sure, you go to our Threadripper Pro, go to Epic, whatever, spend a ton of money on that. I already said I think most people on 6 cores could do with more. Some people on 4 cores could do with them. If you're building a NAS, you don't want a fucking 24 core monster. You just want a few cores and lots of connectivity. You want lots of storage. If I wanted lots of M.2s in a RAID 1, RAID 10 or something like that, yeah, sure. Why should I want 24 cores for that when it's the PCIe lanes that I'm actually interested in? It's the SATA connections I'm interested in. So here's my thought. Why can we not have a high-end platform that fits a normal CPU? Ryzen 3, Ryzen 5, Ryzen 7, Ryzen 9, mainstream CPU from any of them, including the 3, bring an Athlon if you want. But it has 2 chipset size that give you 48 more SATA. You're making the CPU cost the same as it would anyway. The platform difference is literally the platform difference. Is that not a better way of doing it? So I can buy my £400 CPU. And if I want to pair it with a really expensive motherboard to give it that Threadripper capabilities without, it's not going to have 8-channel or quad-channel RAM. It's not going to have ECC. Those professional server workstation things are going to be still on that platform. But just in terms of I/O, I'm going to have the ability to have the same number of cores I would on the mainstream platform because it is the mainstream CPU, but on a better platform. I can pay more for the motherboard without paying more. Is that not a better scenario than saying, you know what? You want lots of USBs, you want lots of hard drives, you want lots of PCIe, and £1,300 on 24 cores. I don't care if you only want 4. Especially as 12, let's be real, before Ryzen 6, 8, 12, 24, These were all high-end desktop. Now 6, mid-range. 16. Remember, 16 in terms of cores competed with the Skylake X N900XE, the absolute top end ad for the HD high performance desktops. Only competed with the top of AMD's. They didn't even have an answer to 3. So yeah. I think this, take this to its logical conclusion, that's a better solution than Threadripper.
Offer the perfect balance of price point and capability.
Unless you want lots of cores, in which case Threadripper.
These boards are designed for performance users who want all the features the AM5 ecosystem has to offer, but may not demand all of the headroom and overclocking support the X series boards make available. These boards will all feature PCIe 5 to an M.2 storage socket so that users can take advantage of the benefits that Gen 5 offers. Now in 2019, AMD was the first to introduce PCIe 4 to our desktop platforms, and now we're bringing in PCIe 5, which doubles the throughput once again, offering a theoretical maximum speed of 32 gigatransfers per second per lane to a range of devices on the motherboard. The first enthusiast-grade PCIe 5 devices entering the market are NVMe storage solutions, and AMD has partnered with Phison, as well as storage device manufacturers like Crucial and Micron to bring this incredible performance uplift to the AM5 platform. Now, speaking of performance, as we develop these next-gen storage solutions with our partners, we're seeing an incredible 60% increase in sequential read performance versus PCI Gen 4 drives. When you think about what gamers and enthusiasts want most, like faster game loads or recalling large models from storage, the PCI Gen 5 ecosystem promises to deliver a fantastic experience. We expect to see the first...
I'm curious actually to see how many people are actually gaming from an NVMe drive. I mean, alright, so I have ridiculous hodgepodge of drives. Like I said earlier, I don't throw away technology. I just add it in. So my storage solution is 256 gig boot drive, a 2 terabytes WD Black from 2011 for mass storage. This stuff doesn't require. Nope, not even music actually. Nothing on there is speed. I have a 500 gig SATA SSD, a 1 terabyte SATA SSD. Those two exclusively for games. I have a 2 terabytes PCIe 4 SSD, NVMe M.2 SSD. That is just for VODs, actually. That is for everything that I stream. All my recordings go to that, so that any video editing I have to do is off of that drive specifically, because that is something that it is very easy to get bottleneck from storage. There's no point having a 16 deal with that if you can't grab the data from storage fast enough to utilize all. That's why I have that. And then I've got something like, is it 12 or 14 terabyte spinning Rust drive that is for films. None of those require speed. They do require point of that. That's the drive situation I have. I have never gamed off of my PCIe 4 2 terabyte SSD. I could if I were a normal person. That would be more than enough storage for the entire machine. In many ways. But yeah, it'll be interesting. So far, up until now, the benchmarks for gaming have shown massive uplift going hard drive to SSD, SATA SSD, and an almost immeasurably small uplift going from SATA SSD to M.2 SSD, even PCIe 3, PCIe 4, negligible. I wonder if solutions like Microsoft Direct Storage are going to change now that the consoles are both using. I believe they're using it. That was my surprise going into PS5 and the Xbox. Why? Because they've gone from incredibly slow shit mechanical drives. They've skipped SATA entirely, gone straight to M.2, which I guess it kind of makes sense because they left it so long that the price of SATA and M.2 basically evened out to be the same. This is why I'd like more PCI games, by the way. Not really a point in buying SATA drive unless they're mechanical. You're buying an SSD, it may as well be M.2 because they're the same price. But I would like to see benchmarks, particularly for direct storage or smart access storage, whatever AMD calls it, pairing SATA SSD with PCIe 3, 4, and eventually 5. I'm expecting even then dramatic diminishing. I'm not expecting it to especially go to M.2 over SATA for the sake of upgrading. You wouldn't buy SATA now. Happen to have, in my case, I would because I have lots of SATA 3. I do not have any more M.2 slots. I've got a PCIe slot for my old X79 system that I could theoretically have one more going into a PCIe slot itself. But that's what we need, more slots, more PCIe. Because people, we want kind of a good thing to depreciate SATA and move to NVMe, because unless you're buying massive hard drives, have done, you have, I'm not poo-pooing that, necessarily need 10 of them. Yeah, I don't, lots of PCIe, lots of NVMe slots on the board. Where you'd put them, how you'd vary them, my job to find out that out, but it's definitely what we should be doing going forwards.
First devices from Crucial and Micron available in the consumer market timed with the introduction of the AM5 ecosystem, followed by new devices from other partners like Gigabyte, MSI, Corsair, and many more shortly thereafter. Our partners will introduce a range of new AM5 platforms covering the features, price points, and capabilities to address the needs of many different enthusiast desktop customers.
Tell me that's not an RGB dot matrix display over the PCIe slot. Got 2 under that. Tell me that RGB dot matrix on the front of your motherboard. Tell me that's not 2 RGB dot matrices. Asus. See, the worst thing is, this is probably not going to be open source. Like, there's an open, I can't remember what it's called, Open RGB, something like that. It's not usable by that. This is going to be a fucking random. My PC, it's under my desk. I can't really see it. But it is a pride parade under there because none of my different RGB systems are compatible with Open RGB. So they're all just on Rainbow. I used to have bicolors. I used to have the pink, purple, blue. My general go-to. Nice, quite snazzy, and do any of that with Linux because for some reason all of these companies have their own competing standards for RGB that can't connect with each other. So if you buy, they're trying. Again, I can see the purpose. They're trying to lock people into an ecosystem. You've got my graphics card, you want my motherboard, you want my, RGB case illumination. Whereas what they should be doing is going to an open standard so you can mix and match all of them. Because really, I mean, I have an Asus motherboard. I do not have an Asus graphics card. But a palette graphic. Your palette especially. If your palette especially, go open standard. Like, I know Palette is one of the biggest GPU manufacturers globally because they're massive in China. But they're not that big in the West. And if you've got the likes of Asus, who are globally huge, and Gigabyte, and ASRock, and MSI actually, got all of those saying, you know what, if you got my motherboard, you have to get my graphics card as well, unless you want everything to look really weird and disparate, connected at all. I would, if I were Palette, if I were any one of the relatively small, like Gainwood, another company that's massive in China, not necessarily in the West, and I would be using open standards just to say, you know what, use our stuff. Very easy to make it communicate with anything. Do it automatically. It's open. Been on Linux for a year. Talking like. Right, let's move on.
Customers. Boards from ASRock, ASUS, BioStar, Gigabyte, and MSI will feature many of the capabilities that you heard about today. I'm so excited about what we're bringing to market with AM5 and the designs our partners are developing around this next generation solution. I can't wait for you to get your hands on the next era of Ryzen desktop computing. And with that, I'd like to hand the stage back to Lisa to show off a little bit of what this platform is capable of.
Yes, let's see the performance.
Thanks, David, for highlighting some of the big advances AM5 will bring to desktop PCs. Now, one of my favorite things to do is show off our new tech, so I'm so excited to be able to do that now with Ryzen 7000. Let's start first with gaming. What you're seeing now is gameplay footage of the recently released Ghostwire Tokyo.
I've been meaning to play
from
Ghostwire
Tango
Tokyo
Gameworks and Bethesda Studios, running on a pre-production version of our 16-core Ryzen 7000 processor. This first-person action-adventure game has rich visuals that help recreate an alternate version of Tokyo. If you look at the current frequency of the CPU reported in the top left corner, you can see that those Zen 4 cores are running around 5.5 gigahertz, with slight variations during gameplay. We designed Zen 4 to run significantly faster than our previous generation, and that increase in frequency can translate into a smoother gaming experience. And while this is just one example, we're really excited for gamers to get their hands on our Ryzen 7000 series.
Gigahertz.
But we know our fans use Ryzen for
That's
more than
impressive.
just gaming. From the beginning, Ryzen has set the standard for high-performance content creation, delivering performance.
Just want to remind you, let's take another history for back in the Bulldozer year and the Pentium 4 era. That was the era of both companies doing really stupid things in retrospect. Where they basically said, you know what, the Intel, particularly during the PS4, the Pentium 4 era, said, you know what, the future is very high frequency. We see 5 gigahertz, 6, 7, 8, 10 gigahertz CPUs. For this, we are going to have to increase latencies internally and produce some bad instructions per clock, but we make up for it with math. That was the gamble they took. And needless to say, it did not take off, not do so well. The AMD Athlon XP, that kind of era, was way better than the Pentium 4. That was, we actually had, AMD was so good back then. I mean, they are again. So yeah, they really took advantage of. In fact, the Intel process was so shit that when they made the Core 2 Duo, they based it on the Pentium 3. That's a thing. And then, failing, years on from that, when AMD produced Bulldozer, they did the exact same thing as Intel did with the Pentium 4. They increased latencies. They said, okay, we've got 4 cores, where we've got 4 integer cores. We have 4. My brain is gone. Clearly, I'm too tired. I've drank too much wine. Scheduler. 4 instruction schedulers and 8 integer cores. It's integer cores, 4 instruction schedulers, 4 FPU. And they made the prediction that graphics card was going to be more important eventually than the CPU. And given the graphics card is just basically a massive FPU machine. Job is floating point. Far more efficiently, so much more effectively. CPU, you know what? There's no point putting 8 floating point calculators on the CPU. Put the graphics card where they belong. Which was a good prediction to make in 2022. That is where we are. Most applications have what's called, hardware acceleration, which basically means off with the floating point onto your GPU. Unfortunately, 2010 was not that year. 2010 was not when that was happening. 2010 was not when you could get away with having shit floating point capabilities on the CPU. Sadly. So all of these things came to fruition, resulting in Bulldozer, Pile Driver, Excavator kind of being. And sadly, it's taken so long for gambles that it made to pay off that the overall performance is now so bad. The gambles that it made. That's why Bulldozer went down in history. But one of the things they tried to do, as we mentioned, is late. Because you get the same bet that Intel made with the Pentium 4, among others. What I'm getting at is when Ryzen was released, absolute opposite. The IPC was so good that in 2017, Lisa Su stood on this stage and she showed it, the 8-core, the 1800X, $500. She compared that with the Broadwell E. Also 8-core. Both of them to 3 gigahertz and a bench, and just marginally the Ryzen 1. They were very similar. Clocked at 3 gigahertz, they were very, very similar. Everyone was excited coming from Bulldozer. Remember, at that point, Radeon was what was really good at the CPU division. People were thinking that maybe they would spin off Radeon as its own company that would be successful, and the actual CPU part of AMD would sink. That was the narrative. That was the expectation. You're quite surprised when Ryzen was released, and it's competitive not just with Intel's Haswell, which people were kind of expecting, maybe if they were lucky. It's actually Broadwell. It was new. It was a high-end desktop it was competing with, and it was doing the same number of cores at half the price. They didn't even announce the 1700, which was, $200 cheaper again. It was mind-blowing. But it's one caveat. The one problem with Ryzen back then was that the reason both CPUs gigahertz, because while Broadwell would boost to at least, seem to remember Broadwell having a boost that was 1 gigahertz. Ryzen 1000 first gen hard limit 4 gigahertz 3.9. And yeah, that had ramifications as well as the intercore latency. based on the TCX design, all of these had implications on single-threaded performance and gaming. Cinebench, media encoding, 7-zip, brilliant. Absolutely fantastic things like that. If you were gaming on this, then it would perform like an i5. So flash forward to 2022, the fact that AMD doesn't have intercore latency. They are 8-core CCX. That problem, gone. Hard limit of 3.9 gigahertz. We just saw it running at 5.5 gigahertz. They have the clock speed advantage over Intel. And they're not doing it without shit comp bulldozer or Pentium. They are, in terms of Ryzen, they are really not. They have so much. The 3000 series was when Ryzen started to get really good. That's when I bought. The Ryzen 3000 series has an IPC advantage. For single and multi-threaded performance actually is in excess of Intel's at the time. It just has that CCX problem of 4-core with the Infinity Fabric between them. It means you are losing performance. Any CPU 1 has to access the cache from CPU 6. It has to go through that and gets a severe latency penalty in doing so, which is a problem. And that's why the gaming performance, the Ryzen 3000 does not match on paper stats of other users. Blender, media encoding, transcoding, encryption, compression, all those things. That processor does brilliantly for gaming. It's okay, it's good. It's not bad. But compared to Intel 10th, 11th gen, wasn't quite. AMD have not only overcome all the hurdles that prevented their processor from performing how well it should have done on paper, but it looks like they are ready to, I say, leapfrog Intel again, but Intel already behind the 5800 X3D, 5800 X3D, and actually looking at Intel, looking at 12900K. The 12900K is good. Taking like 200 watts to beat 5950X. And let's remember, the 12900K is 50% performance cores, 50% efficiency cores. 5950X is 100% performance core. So, and it's drawing less power at that. So, I think we're in for an exciting time. Both release these processors. I can't remember a time when the competition between these two companies is fierce, when they were both simultaneously so good. Yeah, AMD beat the shit out of the Pentium 4. Yeah, Intel beat the shit out of Bulldozer. Yeah, Ryzen 1000, 2000, 3000. One was better for some tasks, the other was better for the other tasks. Neither of them was a master of all trades. How? Now this is kind of interesting.
That was previously only available in a workstation class processor. Ryzen 7000 will extend that even further. Now let me show you a Ryzen 7000 processor running the popular Blender 3D modeling software. On the right is the Ryzen 7000 system, and the left is a competitor system. Both CPUs are 16 cores and rendering a custom image of our next-gen Ryzen desktop CPU with Blender maxing out the core and thread count.
Oh god,
of
this
those
is not even
processors to
close.
complete the render as quickly as possible. As you can see, the Ryzen 7000 system completes the process 31% faster, which means creators spend less time waiting and much more time creating. So hopefully you can see why we're so excited about our next
That was
generation
not even
Ryzen
close. This
7000
wasn't
CPUs
even
and
like
AM5 platforms.
the photo
You'll hear a
finish
lot
of
more over
the
the coming
1800X
months, and you
versus
should
the
expect Ryzen
6900K.
7000 processors will be available starting this fall.
I wonder what the follow-up to Alder Lake's going to be like.
It's been fantastic spending some time with everyone today. Let me close with a recap of the news. New ultra-thin and gaming notebooks powered by Ryzen 6000 series and AMD Advantage with leadership performance and battery life are available now. Mainstream notebooks based on AMD Mendocino will be available starting in Q4.
Ah,
and
the Steam
Ryzen
Deck
7000 and AM5
APU.
are coming this fall. Thank you all so much for joining us today. We look forward to seeing you in person again soon. Have a great Computex 2022.
Not gonna lie, that took about an hour and a half longer than I expected it to, mainly because I kept pausing it and yakking on about fuck all. That's fun. As a result, I'm incredibly tired. I expected to be done by midnight. It's approaching 2 in the morning, and I have work to technically do. Let's go to BRB. BRB. I think I've said everything I want to say about those while I was doing them. Let's go on a raid. I'm incredibly tired. I'm gonna go sleep, and I think tomorrow, hopefully tomorrow, I'm gonna go back and more Devil May Cry 5. That's fun. Yeah. Should we go see Bailey? Go see some Dragon Age Inquisition. Evolsigam. It's Magic Love backwards. Great. Oh, it looks like he's doing Trespass DLC. Great. Is it Trespass? Anyway, I'm going to say goodnight, and I hope you enjoy this rambling on about Computex from Nvidia and AMD. I enjoyed it. Had fun. So yeah, see you tomorrow. Good night.